Imagine standing in the late-night quiet of your own backyard, the air feeling sharp and dry, and pointing a modest telescope toward the dark ribbon of the cosmos. You are looking not at a star or a galaxy, but at an interstellar vagabond, a visitor from another immense sun, known to us as 3I Atlas. For centuries, we have quietly searched for profound signs of coordinated movement in the heavens, but what the amateur astronomer, known as Ray, captured was 5 distinct points of light, arranged in a quiet ring, circling an object that was never supposed to be here. This subtle, precise formation, caught in his unpretentious, consumer-grade equipment, was so eerily geometric that it seemed to violate the very grammar of natural, random chaos. The grounding data is simple and unyielding. Comets are messy. They are irregular, tumbling chunks of ice and rock, and when they warm up near the distant sun, they fire off asymmetric jets, creating dynamic, beautiful chaos. Nature, in this cosmic domain, does not favor symmetry. Yet, here was a pattern, not random, not scattered, but coordinated, a precise ring of light surrounding an object that arrived from profoundly beyond our own solar system. This created a subtle, disturbing paradox. If the spots were just ephemeral dust clumps in the coma, they should flow outward and dissipate rapidly, pushed by solar radiation. Material does not orbit a comet nucleus. It merely drifts away. But Ray's 5 bright points persisted. They remained subtly coherent, shifting only slightly across a series of captured minutes, an implication of underlying structure, or, perhaps, design. What if this coherence was not a visual illusion, but a quiet, profound, intentional reality? What if this interstellar visitor brought along distinct escorts, traveling in a subtle perimeter maintained by something beyond mere gravity and ice? The ancient whispers of messengers and cosmic voyagers echo in the sterile, modern halls of scientific inquiry. This is the irresistible pull toward unanswered questions, and in the profound face of this startling, quiet symmetry, the National Aeronautics and Space Administration, the primary gatekeeper of our cosmic stories, has gone unusually, conspicuously quiet. Their customary flow of orbital elements and preliminary data has dramatically slowed. Feel that subtle tension. It is the exquisite, calm tension of profound wonder meeting profound silence. It asks you to peer deeply into the grainy, humble image and quietly confront the possibility that the language of the universe might be more complex, more geometric, more profoundly organized than we have dared to admit. Drop a comment below telling me what time it is and where you are listening tonight, and what you think about this new, unsettling development. The subtle light stretches like silk across the void, but the geometric pattern quietly remains. We may already be part of the experiment. The entire quiet story of 3I Atlas begins with a single, crucial photograph. Not a complex data stream from a billion-dollar orbital facility, but a humble snapshot taken from a suburban driveway, where an amateur astronomer named Ray pointed a telescope, perhaps 10 inches or 12 inches in diameter, and quietly captured something that entirely defied the established, predictable grammar of space. You are gently asked to quiet your mind and look meticulously at the image. 5 distinct bright points emerge from the pervasive noise. They are subtly arranged in a perfect ring around the central, fuzzy core of the entire comet. This is not simply a random cluster of errant, chaotic dust, because those 5 points persist across multiple captured frames, separated by minutes, and sometimes mere seconds. If this were merely sensor noise, or hot pixels, as the precise technical term goes, they would flicker randomly, coming in and out of coherence entirely. Instead, they quietly hold their geometric formation. They stay profoundly together, almost like a subtle, coordinated unit. The question that immediately arises, a question so simple and immediate, it cuts through the complex noise of technical data, is profound. Why? The immediate, rational explanation, which any seasoned professional astronomer would first reach for, is subtle diffraction. This is the natural phenomenon of light bending profoundly around the sharp edges of the telescope's internal optical components, which inevitably creates rings or distinct spikes around a bright, intense object. It is a known feature, an expected artifact of the instrument itself. However, the 5 distinct points quietly refuse to adhere to this simple explanation. Diffraction patterns depend intricately on the precise angle of the incoming light. They should subtly shift and change shape as the telescope diligently tracks the object across the sky. Yet, the 5 points in Ray's images do not behave that way. They persist. They remain roughly equidistant from each other. And, crucially, diffraction typically creates rings or linear spikes, but it does not, in the standard model, produce 5 distinct, evenly spaced bright nodes around a moving, active, outgassing body. The entire geometry is, statistically speaking, deeply weird. The second suspect, the logical next step in scientific deduction, is the subtle smearing of background stars. Perhaps Ray's meticulous tracking, though generally decent, was slightly imperfect, causing extremely distant stars to smear into subtle arcs that simply happened to fall into a perfect ring around the central comet. But here again, the observational evidence does not quietly cooperate. Ray's exposures were quite short, meaning the stars appear as crisp, distinct points, or at most, very slight, short streaks. Moreover, stars do not, by definition, appear to orbit a comet. They drift across the field of view in profoundly straight, parallel lines. The 5 points simply do not behave like distant stars. They maintain a specific relational quality to the comet's core. What makes the observation so profoundly unsettling is the movement subtly observed over the short period of time. Ray did not just take one isolated picture. He captured several sequential sequences, spanning approximately 30 minutes to 40 minutes in total. And in those sequences, the 5 points exhibit subtle, minute shifts. They change position relative to one another and, most importantly, to the central core of 3I Atlas. Frame 20 shows one distinct configuration. Frame 14, captured some minutes earlier, shows a slight, measurable rotation, and frame 9 shows them shifted yet again. To the careful viewer, watching this subtle process happen in quiet sequence, it quietly looks like something is moving, something is elegantly circling the main body. This apparent coherence and subtle, coordinated motion is the profound heart of the entire enigma. Professional optical scientists, the ones who spend their entire careers meticulously looking at light, are profoundly split. One group sees exactly what they are trained to see, a predictable cluster of subtle artifacts created by asymmetrical dust jets combined with over-aggressive digital processing. Comets are known to eject material unevenly, and a spinning nucleus with 5 active vents can certainly produce bright, distinct clumps of dust that, from a certain, unique angle, appear to surround the nucleus. Add the intense digital sharpening algorithms that amateur processing often favors, and you can easily create the subtle illusion of geometric structure. They call it an artifact cluster, a precise technical term designed to be reassuringly dull. But the second group of scientists is profoundly unsettled, and their quiet disquiet echoes Ray's initial feeling of unreality. The perfect, even spacing of the points is a significant, profound worry. Even if you grant generous, charitable assumptions for dust dynamics and projection effects, acquiring 5 roughly equidistant bright nodes is statistically a deeply weird, unlikely coincidence. Moreover, the time evolution of the profound features is profoundly bothersome. If these 5 points were just random dust clumps in the immense coma, they should rapidly disperse. They should simply flow outward, gently pushed by the sun's radiation and the comet's outgassing pressure. The coma is a profound cloud that naturally expands. Material does not naturally orbit in this precise, coordinated way. Yet, Ray's 5 bright points remain subtly coherent. They shift, but they do not quietly dissolve. They refuse to blur into the pervasive background haze. Their persistence profoundly implies a structure, something that is quietly holding those bright regions in a coordinated pattern. The public reaction, meanwhile, immediately reached for the mythic narrative. Online communities exploded with theories. The pattern was immediately called too perfect to be random. They were instantly christened escorts, or far more aggressively, subtle probes. The interstellar visitor was no longer merely a comet, but something quietly masquerading as one. This is the unyielding human condition. We are profound, desperate pattern recognition machines, and when we see symmetry and apparent coordination, a primal part of our mind immediately suspects deliberate design. The legitimate question that quietly remains, asked by careful scientists and armchair enthusiasts alike, is profound. What configuration of purely natural processes produces this precise pattern? And why does it look so strikingly similar to something maintaining a profound, deliberate perimeter? To understand the quiet question fully, you must allow your mind to slow down and consider the deep, unyielding symmetry. The ancient Greeks profoundly believed that a circle was the perfect shape. Here, in the data, a rough, shifting circle of light quietly appears where only profound, predictable chaos was expected. We are quietly forced to dig into the rotation of 3I Atlas, to look at the bizarre spin that subtly complicates every easy explanation, a rotation that will lead us further into the mystery. We are following the light into the dark, and the comet absolutely refuses to obey the comfortable, old rules. The cosmos is never truly still. Even the seemingly solid, frozen world of a distant comet is an immense, chaotic world of motion. Comets spin. This is perfectly normal. They are vast, irregular chunks of ice and rock tumbling through the cosmic deep, and the uneven, asymmetrical heating from the distant sun causes the material to subtly vaporize. creating powerful jets that push asymmetrically on the tiny nucleus. This is the simple, profound way rotation begins or changes over time. Most comets rotate slowly, with a full period of rotation measured in hours or even whole days. To build a clear picture of that rotation requires patient, meticulous work, tracking subtle changes in coma structure over a period of weeks. The profound oddity that Ray subtly observed over a period of less than 2 hours is that 3I Atlas appears to be spinning fast, uncomfortably fast, and the manner of its rotation does not quite fit the standard, expected script. Ray quietly noticed this subtle strangeness while meticulously reviewing his many captures. The comet's coma, that delicate, fuzzy, immense cloud of gas and dust, was not profoundly static. Over intervals as short as 60 seconds to 90 seconds, the entire distribution of density in the coma subtly shifted. Brighter regions appeared to elegantly rotate, and fainter areas quietly emerged, as if the entire object was elegantly turning, presenting different faces to the distant telescope. If you have ever watched the mesmerizing, elegant sweep of a lighthouse beam across the dark, vast sky on a dark night, the subtle effect is similar. The light source does not move, but the powerful beam does. In the profound case of 3I Atlas, the comet itself seemed to be the rotating source, and the profound beams were powerful jets of erupted material gently flowing from its vast, complex surface. The precise technical details of the camera system briefly complicate the matter, as the entire optical path can sometimes introduce subtle mirror flips, making the rotation appear clockwise in some images and counterclockwise in others. But when professional scientists apply the necessary, meticulous corrections for this mirroring effect and track the actual motion of profound features within the coma, a predictable pattern emerges. The object is undeniably rotating, and it is doing so in a way that suggests a surprisingly short period, perhaps only a few mere minutes. This is a startling figure. A rotation period of merely minutes is not at all typical for a comet nucleus that is likely several kilometers across. Most comets rotate slowly because they are essentially vast, structurally weak rubble piles. Rapid, immense rotation generates powerful centrifugal forces that would inevitably overcome the weak gravitational embrace and the mechanical strength quietly holding the icy material together. A comet spinning with a rotation period of a few minutes would be under enormous, profound internal stress. While not strictly impossible, perhaps the object is exceptionally small, or profoundly unusually strong, or bound by exotic materials. It immediately raises profound, quiet questions. The questions subtly deepen when you meticulously examine specific captured frames. Frame 20 shows a bright core with a slight, subtle asymmetry. Frame 14, captured approximately 6 minutes later, shows that asymmetry has rotated roughly 30 degrees. Frame 9 shows it shifted yet again. Mapping these subtle changes onto a rotation curve produces a rotation period somewhere between 15 minutes and 25 minutes. This is fast, uncomfortably fast, but perhaps it is not pure, simple rotation. Maybe the entire motion is a profound precessional wobble. Imagine a child's spinning top. As it spins, the entire axis itself rotates in a slower, circular motion. This is precisely called precession, and it creates a complex, intertwined movement that can make surface features appear to subtly shift in strange ways. Comets are well known to precess, especially when the profound outgassing is profoundly asymmetric. The powerful gas jets act like tiny, untamed rocket engines, gently pushing the nucleus off balance, which subtly induces a continuous wobble. If 3I Atlas is precessing rapidly, it could entirely explain the minute-scale changes Ray subtly observed. Precession has a subtle structure. It is profoundly periodic, and that profound periodicity, even when quietly born from natural physics, can look strikingly intentional to the human eye. Another possibility, deeply rooted in fundamental comet physics, is a profound rotational wobble driven by subtle outgassing torque. When material jets violently away from the comet, it carries kinetic momentum. If the powerful jets are active on one side and dormant on the other, this creates a torque that changes the nucleus's immense spin rate. The European Space Agency's Rosetta mission quietly observed this on Comet 67P, watching the entire nucleus slowly change its rotation over a period of months. But 3I Atlas appears to be changing much faster, over mere minutes, not months. This would profoundly imply either tremendously strong, powerful outgassing, or some unknown force subtly affecting its motion. The final, elegant technical explanation, one that would make the entire mystery profoundly vanish, is the subtle artifact of imperfect tracking. If Ray's telescope did not perfectly follow the comet's immense path across the sky, the coma would slightly drift in the frame, and stacking those drifting images could easily create the subtle illusion of rotation where none actually exists. The technical term for this is field rotation, and it is a common, profound issue in astrophotography. However, Ray's background star field does not show the expected, profound drift. The stars remain crisp, clean points. Their relative positions are highly consistent. If field rotation were the culprit, the stars would betray it immediately. They do not. This profound absence of a simple, easy explanation is where the mythic narrative inevitably enters the quiet conversation. If 3I Atlas is rotating rapidly and, crucially, if that rotation is stable rather than profoundly chaotic, it subtly begins to resemble something profoundly familiar from our own technological history. It quietly looks like a spacecraft, an object profoundly designed to maintain orientation, perhaps using controlled attitude adjustment. Our own aerospace engineers profoundly rely on spinning a craft up to stabilize it. The rotation Ray observed looks too stable. It looks, to the eyes, quietly searching for design, like something profoundly under intentional control. To be profoundly clear, there is no evidence of artificiality. None, but the geometric pattern immediately invites the quiet comparison, and once that subtle comparison enters the mental landscape, it is remarkably difficult to shake. The most elegant and naturally profound counter-explanation to both the 5-point anomaly and the rotation anomaly is a simple, combined feature. Imagine a comet nucleus with 5 evenly spaced, active vents profoundly located around its vast equator. As the entire nucleus elegantly rotates, each vent fires in quiet sequence, creating bright, discrete pulses of dust that appear to orbit the entire object. From our distant, narrow perspective, we would not see individual, momentary jets. we would see bright points that maintain their position relative to the nucleus, moving exactly as it turns. This is a natural, physical explanation. It profoundly fits the laws of physics, but it requires an almost perfect, profound arrangement of those 5 specific vents. Which brings us quietly back to the original, profound problem. Why is it so symmetric? Why does it look so profoundly designed? The silence from the National Aeronautics and Space Administration on the precise rotation parameters is, itself, profoundly conspicuous. Usually, an interstellar object triggers a rapid, profound release of preliminary data, but with 3I Atlas, the usual flow has dramatically slowed. Perhaps they are simply checking and rechecking their complex models. Perhaps they are seeing the same uncomfortable weirdness that Ray captured and are meticulously trying to figure out how to explain it without sparking a media frenzy, a profound phenomenon they know all too well from the first interstellar visitor, Oumuamua. We are left with a spinning top of the cosmos that turns too quickly, too smoothly, with features that are both regular and profoundly strange. We are left quietly wondering if the strange rotation is a key to understanding the profound 5-point anomaly, or merely an elaborate, graceful distraction. The meticulous study of comets often begins with the quiet recognition of their fundamental messiness. They are not smooth, orderly, symmetric worlds. They are jagged, irregular bodies, profoundly pockmarked and fractured, coated in dark dust, and riddled with volatile, icy pockets that heat unevenly as the comet approaches the intense light of the sun. When the frozen material vaporizes, it blasts violently out from localized, random vents, creating asymmetrical jets that twist and spiral as the entire nucleus elegantly rotates. The subtle result, to the astronomer's quiet eye, is profound chaos. Beautiful, unpredictable, dynamic chaos. No 2 comets look exactly alike, and no single comet looks the same from one week to the next. This is the bedrock of our quiet, fundamental understanding. So, when you look upon an image of a comet that displays repeating, perfect, symmetric structures in its coma, your first, deepest thought must be profound skepticism, because nature, in this specific realm, does not typically do symmetry, not like this. Consider the short history of interstellar visitors. The first confirmed object, Oumuamua, barely outgassed at all. It subtly showed non-gravitational acceleration, suggesting some gentle release of material, but it left no visible coma and no jets. It moved as if it were being gently pushed, yet left no visible trail behind it. The second visitor, 2I Borisov, was the profound opposite. It displayed strong activity, with a bright, expansive coma and clear evidence of carbon monoxide outgassing. Its jets shifted and flickered. It was chaotic, profoundly asymmetric, exactly what you would expect from a purely natural comet. Neither of these 2 prior visitors showed anything remotely similar to the 5-point formation captured by Ray in his images of 3I Atlas. Neither looked coordinated. Ray's footage, however, shows something deeply different. The 5 bright points do not merely exist as independent lights. They subtly align with distinct structures within the coma itself. If you enhance the contrast and meticulously trace the faint streamers of dust, You can subtly see radial patterns extending powerfully outward from the nucleus. These patterns intersect precisely with the bright nodes. This looks like jets, multiple jets, firing simultaneously, each one creating a bright region where the vast dust profoundly scatters the light of the immense sun most efficiently. But here is the inherent, profound problem that troubles the careful scientist. The simultaneous activation of 5 jets that are roughly equidistant should not occur naturally. Comet geology is fundamentally random. It is shaped by accretion and violent collisions over billions of years. Finding 5 active regions, spaced approximately 72 degrees apart, around the circumference of a nucleus, is statistically unlikely. Not impossible, but profoundly unlikely enough to compel profound, quiet wonder. Real, scientific explanations for this profound phenomenon do exist. One distinct possibility is the precise orientation of the nucleus's spin axis, aligning precisely with our line of sight to the vast sun. If the rotation axis is oriented just right, and if there are 5 vents precisely clustered near the equator, they could activate sequentially as the nucleus turns. From our distant perspective on Earth, a simple trick of optical projection would make all 5 appear to be lighting up at once, even though they are firing one after another. It is the same visual effect as a powerful rotating lighthouse beam that looks constant if you stand in precisely the right spot. This explanation is mathematically sound. It is consistent with the fundamental laws of physics, but it requires a very specific vent distribution and a very specific coincidental alignment. The profound need for multiple perfect coincidences begins to quietly pile up. A second profound idea involves resonant structural features buried deep within the nucleus. Imagine a nucleus whose internal structure cracks or layering, profoundly shaped by thermal stress, over eons, channels the escaping gas in predictable, specific directions. As the entire nucleus rotates, these pathways could create repeating patterns. Some asteroids exhibit similar behavior, where their spin rates lock into specific, profound, resonant states, causing surface features to repeat in profoundly symmetric ways. If 3I Atlas has an internal structure that promotes this kind of resonance, the jets could appear organized without being artificial. They would simply be following natural pathways carved by deep geology, but in a manner that happens to look extremely regular. Again, this is possible, but it requires highly specific, profound, unusual geological conditions. Then, there is the phenomenon of subtle shadowing, which adds another confounding layer to the mystery. In several of Ray's meticulously processed frames, there are dark ridges in the coma, not merely dim regions, but strikingly dark areas, as if something solid is blocking the intense light. Shadows profoundly imply structure. They imply something rigid enough to cast a distinct silhouette. In a diffuse, uniform cloud of gas and dust, you do not expect to see sharp, distinct shadows. Everything scatters and glows softly. But if there is a rigid underlying shape, such as a fractured nucleus with large, distinct lobes, those lobes could create shadow zones as they subtly turn. The Rosetta mission saw this on Comet 67P. Its distinct, rubber duck shape cast shadows across its own massive surface. 3I Atlas could be similar, a weirdly shaped nucleus, rotating and casting shadows through its own vast coma. This would explain the dark ridges, and why those ridges shift between frames as the nucleus turns. The only subtle trouble is the shadows do not behave quite right. They shift, yes, but they also seem to profoundly track with the bright points. Where a bright node appears, there is often a corresponding dark ridge nearby, as if the two are physically linked in some way. This is profoundly more difficult to explain with simple shadowing. It suggests a kind of organized, non-random structure in the coma itself, perhaps lanes of dust that are profoundly clumped together, creating both bright reflections and dark gaps. Or, the simplest, most mundane explanation, the dark ridges are a profound digital artifact. Aggressive sharpening can create dark halos around bright objects, mimicking shadows where none actually exist. Ray's processing was, by his own humble admission, aggressive in its sharpening, but even in the less processed frames, the shadows appear faintly, and so we quietly return to the profound, mythic question that keeps subtly creeping into the serious conversation. Could the shape be engineered? Could the 5 jets be nozzles? Could the rotation be precisely controlled? This sounds fundamentally absurd, until you are reminded that we ourselves have sent probes beyond the solar system, voyagers, pioneers, New Horizons objects profoundly designed to maintain their orientation, using small thrusters and subtle spin stabilization. If we can quietly achieve this, why couldn't something else? It is pure speculation. There is no concrete evidence, but the profound, unyielding geometry keeps asking the same essential question. Why is it so symmetric? Why does it look so much like a deliberate, intentional configuration? And why, when you try to explain it with only natural processes, do you constantly require special conditions, perfect alignments, and convenient, unlikely coincidences? We are looking for the truth buried beneath the layers of processing and assumption, and the comet will not give up its secrets easily. Every captured image is a vessel quietly carrying secrets. That is the quiet wisdom well known by professional astronomers. The beautiful, glowing nebula or the distant galaxy you see is merely the surface of the immense data. Beneath the visible layer, profoundly embedded in the file itself, is a second layer of profound, cold information. Exposure times, sensor temperatures, precise timestamp data, accurate tracking coordinates, and buried even deeper in the actual pixel values are subtle clues that can reveal whether what you are looking at is merely an artifact or something profoundly natural, or even something fundamentally impossible. Ray's images of 3I Atlas are no exception to this. On the surface, they reveal the 5 bright points and the strange, fast rotation, but in the subtle, hidden metadata, in the precise details he may not have even noticed, there are quiet hints of something stranger still. Not proof, not yet, but profound hints. And sometimes, profound hints are far more profoundly unsettling than any final answer. Start with the short star streaks. When you perform meticulous astrophotography, your telescope must diligently track the sky, compensating for the relentless rotation of the Earth, so that your target remains perfectly centered. If the tracking is perfect, the background stars appear as pinprick points. If the tracking is slightly imperfect, the stars smear into short, faint lines. This is perfectly normal. Ray's images show star streaks, as entirely expected, but if you look very closely, some of those faint streaks are bent, not dramatically, not in a way that profoundly screams of error, but subtly curved. It is as if the tracking speed suddenly changed mid-exposure, or, far more profoundly, as if the stars themselves moved in gentle arcs, rather than in perfectly straight, parallel lines. That should absolutely not happen. Stars move linearly relative to a tracking telescope. If the tracking is simply off, the streaks should be straight, merely angled wrong. Curved streaks suggest either a non-uniform tracking error, which would immediately imply a serious mechanical fault in the telescope's elaborate system, or subtle, rapid micro-movements of the object being tracked, movements that are profoundly inconsistent with the gentle, smooth trajectory of a normal, typical comet. A comet's position is highly predictable. Its path is a smooth curve, profoundly governed by gravity, with only tiny perturbations from outgassing. Those perturbations are measurable, but small. They do not cause sudden, rapid jerks or massive, rapid oscillations. They nudge the comet gently over a period of days or weeks. So, if 3I Atlas were wobbling or shifting its position rapidly enough to actually bend the faint star streaks, that would be highly unusual, very unusual. It would profoundly imply powerful, internal forces acting upon the object that are not present in the standard models. Solar radiation pressure alone cannot do it. Outgassing torque would have to be absurdly strong, and gravitational interactions with anything nearby are profoundly ruled out, simply because there is absolutely nothing nearby. Yet, the star streaks subtly curve, and that is a quiet, hidden problem in the metadata. Next, you look at the subtle color gradients. Ray's system, like most amateur setups, uses an RGB sensor, red, green, and blue pixels meticulously arranged in a grid, each recording different precise wavelengths. When these three are combined, you get a full color image. Comets naturally show color variations based on the dust composition and the subtle size of the grains. The coma can be reddish near the nucleus, where larger particles dominate, then quietly fade to bluer tones further out, where smaller grains scatter the sun's light more efficiently. That is expected. What is not expected are sharp, distinct transitions, distinct blue-green zones that profoundly refuse to blend smoothly. Ray's images show exactly this. Patches of coma with colors that look profoundly wrong for a purely RGB setup, observing simple, reflected sunlight. They are too saturated, too distinct, almost like emission lines, the type of profound feature you would see if specific gases were intensely fluorescing. But Ray was not using the narrowband filters specifically designed to isolate precise wavelengths. So, where are these intense, distinct colors truly coming from? One explanation, again, is simply profound sensor noise. Digital sensors produce artifacts, especially during long exposures. Hot pixels glow brighter than they should. Cold pixels simply drop out entirely, and a complex process called Bayer matrix interpolation can create profound false color gradients where none actually exist. If Ray's sensor was noisy, and his aggressive processing profoundly amplified that noise, the color zones could be entirely artificial. But noise tends to look random, grainy, and chaotic. These color zones, however, have quiet structure. They align with the 5 bright points. They follow the overall coma geometry, which profoundly suggests they are not merely random noise. They are responding to something physically real in the image. Maybe it is dust with an unusual composition. Maybe it is contamination in the optical path. Or maybe something in the coma is genuinely emitting light in ways we do not expect from a typical comet. Ray's stacking strategy, the cornerstone of amateur astrophotography, is another key piece of the entire puzzle. He did not simply average his captured frames. He cropped them tightly around the comet, meticulously aligned them precisely, and then applied variable sharpening, light sharpening, to preserve the overall subtle structure, but heavy sharpening to bring out the faint, hidden details. He then adjusted the contrast curves, brightening the dim regions and compressing the bright ones. Every step is standard technique. Every step is defensible, but every single step also introduces the profound risk of amplifying artifacts. Sharpening can transform faint sensor noise into the appearance of real structure. Contrast adjustments can make random fluctuations in brightness look like coherent features, and even tiny alignment errors can create subtle ghost images that seem to orbit the target. Stacking is immensely powerful, but it is also profoundly dangerous if not handled with forensic, meticulous care. Ray, like most amateurs, was focused on making the final image look good, not on ensuring perfect forensic accuracy. The professionals who have quietly reviewed Ray's footage have used an interesting, unsettling phrase: consistency in inconsistency. What they profoundly mean is this: the anomalies are not random. The 5 bright points do not flicker in and out arbitrarily. The color zones do not shift chaotically. The curved star streaks do not appear in random frames. There is a hidden, subtle pattern to the weirdness, and patterns subtly suggest underlying causes. Whether those causes are the artifacts of imaging and meticulous processing or real physical phenomena remains profoundly unclear. But the fact that the strangeness repeats, that it has quiet structure, means it is not merely profound noise. It is a signal. The quiet question, the only question that truly matters, is a signal of what? The silence from the National Aeronautics and Space Administration grows louder with each passing day. Ray's footage went viral almost instantly. The agency must have seen it. They must have tasked the Hubble or the James Webb Space Telescope to take a precise look. Yet, there is no official statement, no preliminary data release, no reassuring press conference, profoundly explaining the anomalies as simple artifacts. Just silence. And that silence is the most fertile ground for profound, unnerving speculation. Because if there is truly nothing profound to see, why not just say so? Why not simply release an image showing a normal, boring comet with normal, chaotic jets and put the whole thing to quiet rest? Unless, of course, their own meticulous images show something remarkably similar. Unless they are seeing the same strange pattern Ray captured and are right now quietly staring at it, trying to decide if the universe has just handed them something profoundly extraordinary, or if they are about to be embarrassed by a subtle, widespread artifact. We do not know, and not knowing is often far worse than almost any answer. The mystery of 3i Atlas is now quietly wrapped in the mystery of human caution. There is a quiet, predictable rhythm to how a powerful space agency releases its vital information. You spot something scientifically interesting. You task a powerful telescope to observe it. You collect the necessary data. You run the preliminary analysis. You write a brief summary of the profound findings, and you issue a public statement or hold a press conference. The entire process, from the initial moment of observation to the final public announcement, typically takes a matter of days, perhaps a week, if the data is particularly complex or requires peer review. The agency must say something. It is profoundly essential for public relations. It quietly reassures the public that the experts are in control, that the strange universe is being monitored, and that meticulous science is quietly happening. So, when the National Aeronautics and Space Administration goes silent, when that fundamental rhythm is profoundly broken, people immediately notice, and they begin to ask a very quiet, very profound question. Why? Ray's footage of 3I Atlas spread with immense, immediate speed. Within 48 hours of his initial profound post, it had been shared thousands of times. Within 72 hours, mainstream science outlets were subtly covering the entire story. Amateur astronomers around the entire world were pivoting their dedicated telescopes toward 3I Atlas, trying desperately to replicate Ray's strange, subtle observations. Some dedicated observers saw hints of the same 5-point pattern. Others saw nothing unusual at all. This inconsistency, naturally, fueled the profound public debate. But the one voice that was conspicuously, profoundly absent was the voice of the National Aeronautics and Space Administration. No tweet, no blog post, no preliminary statement to simply say, "We are aware of the amateur footage and are investigating." Just profound silence. And that silence, in the hyper-connected age of instant communication, felt profoundly deliberate. Normally, the agency is prompt. When Oumuamua appeared in 2017, the National Aeronautics and Space Administration released data within days, orbital parameters, preliminary size estimates, reflectivity measurements. When 2I Borisov appeared in 2019, the same predictable pattern held. They confirmed its interstellar origin almost immediately and provided regular, transparent updates as it passed through the immense inner solar system. The public felt, quite rightly, included in the profound process of discovery. But with 3I Atlas, something is profoundly different. The object was detected. Its interstellar trajectory was quietly confirmed. Then, quiet. A scheduled briefing was announced, then suddenly postponed, then rescheduled, then postponed again. Officials cite the standard, predictable excuses, ongoing analysis, and data calibration. But those excuses ring hollow when amateur astronomers are capturing and sharing profoundly compelling images in real time, and the agency responsible for the most powerful telescopes ever built has nothing whatsoever to show. The internal chatter, if the persistent rumors are to be believed, tells a more complicated story. People claiming to have quiet connections inside the Jet Propulsion Laboratory whisper of early Hubble stacks that showed structural anomalies in the coma, features that should not be there, patterns that seemed to match what Ray captured, but with a far higher resolution and a vastly superior signal-to-noise ratio. These are only rumors, of course. They are unconfirmed. They are the kind of subtle stories that circulate in forums and private messages between enthusiasts who know people who know people. But the rumors persist with an unsettling specificity. They mention image processing pipelines detecting geometric structures. They reference internal emails that discuss whether to classify certain observations as artifacts, pending further review. They describe quiet meetings where careful scientists debated how to present the profound findings without triggering immediate speculation about artificiality. There is no evidence of outright profound secrecy, no smoking gun, no whistleblower leaking classified images. The National Aeronautics and Space Administration operates transparently most of the time, bound by policies that require public access to publicly funded data. But those policies include crucial caveats. Data can be temporarily withheld if releasing it prematurely might compromise scientific integrity. If there is genuine concern about artifacts, about misinterpretation, about causing public alarm over something that might turn out to be deeply mundane, the agency can and will delay. They can take their time. They can ensure that when they finally speak, what they say is bulletproof, absolutely beyond any reproach. The only problem is that delay creates a vacuum, and a vacuum, in the vastness of the cosmic mystery, is instantly filled with speculation. Every single day, the agency stays silent. The subtle conspiracies grow a little stronger. The questions become a little sharper. The fundamental public trust quietly erodes a little more. Plausible, real explanations for the delay do exist. When you are meticulously dealing with faint, distant objects, data processing is profoundly complicated. Raw telescope images are inherently noisy, filled with cosmic rays, scattered light, and instrumental artifacts. You must calibrate carefully, subtract the immense background noise, register the frames, and stack them properly. If the process is rushed, you risk releasing images that look dramatic, but are actually just noise amplified by poor processing. The National Aeronautics and Space Administration learned this lesson decades ago. The official reasoning is simple. It is better to be slow and right than fast and wrong. That is a deeply defensible position, until you realize that Ray, with his garage-level equipment and basic stacking software, produced an image compelling enough to go instantly viral. If he can do it in a weekend, why can the National Aeronautics and Space Administration not do it in 2 weeks? The need for multi-wavelength confirmation is another profound factor. Professional astronomers do not just rely on visible light. They require infrared data to measure the precise temperature and dust emission. They need ultraviolet data to detect gas fluorescence. They want spectroscopy to identify the specific molecules present. Assembling all these disparate observations, coordinating different powerful telescopes, and synthesizing the profound results takes substantial time. It is not laziness, it is rigor. You want the full picture before you make a definitive claim. You need to know if the bright points Ray captured show up in infrared, because if they do, they are real, physical structures emitting profound heat. If they do not, they are likely optical artifacts. That difference is everything. It is the difference between a profound, world-changing discovery and a quiet, institutional embarrassment. So, the National Aeronautics and Space Administration quietly waits. They collect, they analyze, and the public, watching the slow turning of the cosmic clock, grows profoundly impatient. The ultimate question is simple. Are they seeing the same 5-point pattern? If the Hubble or the James Webb Space Telescope captured images that show a smooth, asymmetric coma structure with no bright nodes, the mystery collapses instantly. Ray's footage becomes a quiet cautionary tale about amateur digital processing. But if their images show the same pattern, or worse, show it more clearly, then the entire game changes profoundly. The discussion shifts from, is it real, to the far more difficult question, what is it? And once you confirm the profound pattern exists, you are forced to explain it. And the natural explanations, as we have explored, require increasingly specific conditions, increasingly unlikely coincidences, until you reach a point where the natural explanations begin to sound just as contrived as the artificial ones. That is the quiet nightmare scenario for the National Aeronautics and Space Administration. Not that 3I Atlas is artificial, but that they cannot definitively prove that it isn't. And in that profound silence, speculation grows. Let us pause the rigors of skepticism for a quiet moment. Let us play a game. Assume, just for the duration of this segment, that Ray captured something profoundly, undeniably real. Assume that the 5 bright points are not processing artifacts, or illusions, or profoundly misinterpreted dust jets. Assume they are actual, discrete objects, or structured phenomena that are diligently maintaining a precise position relative to the comet's nucleus as it elegantly spins and travels through the vast, cold darkness of space. This is a massive assumption. It may be entirely wrong, but assumptions, like any intellectual tool, allow for a crucial, imaginative exploration. They permit us to meticulously map the profound space of possibility. They allow us to ask, if this were true, what would it look like? What fundamental physics would it absolutely require? And what configurations of matter would actually make profound, scientific sense? We are now exploring the escort hypothesis, not as quiet believers in the myth, but as forensic investigators meticulously mapping the cosmic domain. First, we consider the simplest, most geological of possibilities. Comets are fragile things. They can, and often do, fragment. Immense tidal forces, thermal stress, and rotational breakup can all split a nucleus into multiple smaller pieces. If 3I Atlas fractured violently at some point in its deep past, those fragments might still be traveling together, held in a loose, subtle gravitational embrace. From our distant, narrow perspective, we would indeed see multiple bright points, each fragment reflecting the immense sunlight, each one subtly contributing to the overall vast coma. The precise spacing would, of course, depend entirely on the initial, chaotic conditions of the initial breakup. But here is the immediate, fatal problem. Gravitational interactions between the fragments would cause inevitable orbital evolution. The pieces would eventually drift away from each other, or, far more likely, quietly collide with each other, maintaining 5 fragments in a perfectly stable ring configuration, held together for the months or years it took 3I Atlas to reach our solar system, would require profoundly precise initial conditions. It is possible, but statistically improbable. Furthermore, fragments orbiting a central body would show periodic variations in brightness as they eclipsed each other or changed their phase angle relative to the immense sun. We do not see that. The 5 points appear to maintain a relatively constant luminosity. This is a strong strike against the simple fragment hypothesis. What about the more elegant, subtle idea of symmetric vent positions? Imagine a nucleus with 5 active regions spaced perfectly evenly around its vast equator. As the nucleus approaches the Sun, these vents heat up and begin ejecting material. Each vent generates a bright plume of dust and gas. From our viewing angle, those plumes appear as discrete, luminous points surrounding the nucleus. This is a natural, physical explanation. It does not require anything profoundly exotic, but it does require the nucleus to have a very specific, geometric shape and internal structure. The 5 vents would need to be at approximately 72-degree intervals. They would need to activate simultaneously or in such quick succession that they all appear active in a single captured image, and the dust they eject must scatter light efficiently in our specific direction. That is a profound multitude of requirements. It is not impossible, but it is a narrow, profoundly specific set of circumstances. The question remains, how did the nucleus quietly acquire such perfectly symmetric vent positions? Random accretion over billions of years simply does not produce regular, geometric patterns. Collisions create chaos, not 5-fold order. So, even if the vents are purely geological, something must have shaped the nucleus in a deliberate way. Even if that shaping was purely natural, the result looks, to the human eye, like it was profoundly designed. The most mind-bending possibilities involve the less understood world of plasma physics. Plasma is ionized gas. It is the most common state of matter in the universe, and magnetic fields can subtly trap and organize charged particles into incredibly stable configurations. In laboratory settings, researchers have created plasma knots, toroidal shapes, profound structures that persist far longer than you would expect from random ionized gas. Could something analogous quietly happen in a comet's coma? If the comet is ejecting ionized material, and if there is a magnetic field present, either from the comet itself or from its complex interaction with the Sun's immense solar wind, the plasma could organize itself into discrete nodes. These nodes would glow brightly as the ions recombined or as the electrons emitted photons. And if the magnetic field geometry were just right, they could arrange themselves in a perfectly symmetric pattern. The immense challenge is, comets are not strongly magnetic. Their nuclei are icy rock. The solar wind provides a weak ambient field, but it is very weak at the immense distances we are discussing. Creating stable, self-organizing plasma structures would require conditions far from what we normally associate with a comet's environment. It is not ruled out, but it is profoundly exotic. Even more speculative is the quiet idea of photonic resonance. Light exerts a subtle, immense force. Radiation pressure is real and profoundly measurable. Photons carry a measurable momentum. In principle, if dust particles in the coma were of precisely the right size and composition, they could form incredibly stable patterns where the outward pressure of the immense sun's light exactly balances the inward pull of the nucleus's weak gravity. These would be photonic resonance points, places where the light from the sun creates standing waves in the dust distribution. This subtle pattern would be geometrically dependent, possibly producing symmetric arrangements. This has been proposed theoretically for other astrophysical systems, but it has never been confirmed observationally. Applying it to 3I Atlas requires the dust to have extremely specific properties and the sun's radiation to interact with the coma in ways that seem profoundly fine-tuned. It raises the quiet question: if such resonances exist, why have we not seen them in any other comet? The exploration of the escort hypothesis has only served to deepen the profound mystery. Even when we allow the imagination to range across all known physical laws, the geometric precision of 5 equidistant points remains a profound anomaly. To fully understand the motion, we must now try to meticulously reverse engineer the event, to construct the 3-dimensional motion of the comet from Ray's flat, 2-dimensional amateur data. We are quietly stuck with a view from Earth, a single, narrow angle on an object doing something profoundly complicated. The question everyone is quietly asking is not just, are they moving, but how are they moving? The answer to that question will quietly determine the precise nature of the structure. You are looking at a spinning comet, millions of miles away, through a telescope that is inevitably subject to the subtle thermal wobbles and the gentle pressure of the breeze. You have taken dozens of exquisite exposures, stacked them together digitally, and sharpened the resulting image. Suddenly, you see the 5 bright points, arranged in a ring, moving in ways that feel profoundly coordinated. The single, overwhelming question is simple. Are those 5 points merely rotating with the comet's nucleus, rigidly locked to its surface, or are they moving around it? Ray's limited data does not afford us the luxury of a Hollywood 360-degree fly-around. We are entirely confined to a 2-dimensional projection of an object that is doing something profoundly complicated in the 3-dimensional void between the vast, distant stars. But the patient, meticulous scientist has subtle tricks for extracting motion from flat images, and some of those tricks can even be applied to modest amateur data. The first technique is called differential luminosity analysis. This sounds complex, but the underlying idea is straightforward and elegant. If you meticulously compare the brightness of each of the 5 points across multiple frames, you can begin to map how their positions and energy are quietly changing relative to the comet's core. If all 5 points get brighter and dimmer simultaneously, they are likely locked to the nucleus, simply rotating with it, as vents or jets are illuminated by the immense sun's light. However, if they brighten independently and in a clear sequence, much like a string of immense Christmas lights elegantly going around a vast cosmic tree, then you might be looking at separate objects that are truly orbiting the comet. Ray's captured frames show a perplexing combination of the 2 profound possibilities. The points do not all pulse together perfectly, but neither do they follow a clean, sequential, predictable pattern. The motion is messier. It feels more organic. This could mean that the comet's rotation axis is tilted profoundly relative to our viewing angle, which creates a complex, intertwined pattern of illumination as different features spin in and out of the light. Then, there is coma backscatter analysis. The coma, the dusty cloud surrounding 3I Atlas, is not merely decoration. It is a powerful, precise, diagnostic tool. When sunlight strikes the dust particles, a portion of that light bounces back toward the Earth. By precisely analyzing which parts of the coma are brightest, researchers can infer the orientation of the nucleus. If the dust is being thrown off a spinning body, the backscatter pattern will shift in predictable ways as different hemispheres face the sun. Ray's images show subtle shifts in coma brightness that certainly suggest the object is rotating, but the period seems short, too short. As noted before, most comets rotate over several hours. The changes Ray captured occurred over a period of mere 60 seconds to 90 seconds. This implies either the extremely rapid rotation we have already discussed, which is highly unusual for an object large enough to hold a coma together, or precession, a wobbling motion, like a spinning top that is beginning to fall over. Precession can create a powerful illusion. A slowly rotating object that is also precessing can appear to change its profound orientation much faster than it actually is. This is due to the combined, dizzying effect of two distinct rotations happening at different rates. But here is where the evidence becomes genuinely weird. If the 5 points are fixed to the nucleus, locked into specific positions on the surface, like vents or craters, then as the entire object rotates, we should observe them move in predictable, large arcs. They should spread out, overlap, and change their relative positions dramatically. Instead, they maintain their spacing. They stay coherently in formation. That subtle persistence is the one fact that keeps the escort hypothesis quietly alive. Some researchers have proposed that the 5 points might not be on the surface at all. They could be vast clumps of dust that have become temporarily trapped in stable orbits around the nucleus, held in place by the nucleus's weak, minuscule gravity and the continuous pressure of its outgassing jets. This phenomenon, known as a trajectorial path, happens when particles are caught in repeating loops, spiraling around the central mass, but never quite escaping or falling back into it. The mathematics of this can profoundly work. Small particles in certain precise size ranges can be suspended in quasi-stable orbits around an active comet. They would certainly appear as bright points because they are reflecting the immense sunlight, while the darker nucleus behind them remains relatively dim. And if the comet is rotating, those particles might maintain their relative positions if they are orbiting at a slightly different, or even faster, rate than the nucleus spins. But there is a second, equally profound problem. For 5 separate dust clumps to arrange themselves in a perfectly symmetric ring and stay there for the duration of Ray's observation requires either an extraordinary coincidence or some powerful organizing force that we do not yet understand. Gravity alone cannot easily explain the symmetric spacing. You would need something else entirely. Perhaps subtle electric fields in the coma, perhaps magnetic structures, if the nucleus holds any residual magnetism, or, the simplest explanation of all, absolutely nothing at all, and the entire symmetry is simply an artifact created by how Ray processed his images. Scientists who professionally study comet rotation, such as those who analyzed Comet 67P during the Rosetta mission, know how incredibly complicated a comet's spin state can be. Comet 67P tumbled chaotically, its rotation axis wandering over time due to the asymmetric outgassing. Jets firing from one side created torque, nudging the nucleus into new, unpredictable orientations. If 3I Atlas is undergoing a similar process, its rotation could be fundamentally changing even as we watch it. Ray's data, unfortunately, cannot definitively answer whether the 5 points are fixed surface features, orbiting fragments, or simply optical illusions. The resolution of his backyard telescope is not high enough. The time coverage of his sequence is not long enough, but the data does strongly suggest complexity. It hints at something far more structured than a simple, chaotically spinning rock. And that subtle hint is what makes this so profoundly tantalizing. Because if you assume, just for a moment, that the 5 points are real, discrete objects in orbit, You can perform a crude calculation of what their orbital period would need to be based on the subtle shifts between rays frames. If those points were truly circling the nucleus, they would complete one full orbit roughly every 3 minutes to 5 minutes. That is an insanely fast orbital period. At that kind of speed, they would need to be physically very close to the nucleus, only a few dozen meters out. Otherwise, the immense centrifugal force would simply fling them violently into deep space. Could fragments orbit a comet nucleus that quickly? Maybe. If the object is dense enough and the fragments are small enough, it is right at the very edge of plausibility, which means we are either looking at an extremely unusual, but still natural, configuration, or we are seeing something else entirely. And until someone points a much better telescope at 3i Atlas and tracks these points over hours, not mere minutes, we simply will not know which it is. But the fact that amateur data got us this close to an impossible answer, that is a truth worth remembering. The vast, intricate machinery of professional astronomy is awe-inspiring. It relies on immense telescopes, the size of entire buildings, powerful computers running complex calibration algorithms that have been refined over decades, and dedicated teams of scientists who have spent their entire careers learning how to precisely extract a clear signal from profound cosmic noise. You would think that absolutely nothing could possibly escape that kind of intellectual and technological firepower, but the long, quiet history of the cosmos, quietly, charmingly, says otherwise. The year was 1995. A massive comet named Hale-Bopp was cruising gently through the vast outer solar system, still more than an entire year from its closest approach to the distant sun. Professional observatories were diligently monitoring it, of course, but their captured images were funneled through automated processing pipelines that were specifically designed to instantly remove anything that looked weird: cosmic rays, hot pixels, subtle tracking errors. Anything that did not precisely fit the expected profile of a smooth, symmetric coma was automatically filtered out as mere noise. Then, a dedicated amateur astronomer in Texas noticed something strange, profound, in his own backyard images. The comet's nucleus appeared doubled, as if there were 2 bright cores instead of the expected one. He posted his images online, and within a few days, other amateurs confirmed his finding. Hale-Bopp had fragmented. There was a smaller, separate piece trailing the main nucleus. The professionals then checked their archived data, and, sure enough, the fragment was quietly there. But their automated pipelines, the ones that prioritize cleanliness over anomaly, had flagged the second object as an artifact and automatically removed it. The amateurs saw it first because they did not implicitly trust the algorithms. They looked at the raw data with human eyes and noticed something that, according to the standard model, should not have been there. Or consider the quiet summer of 1994. Comet Shoemaker-Levy 9 was about to smash violently into the planet Jupiter in what would become one of the most widely watched astronomical events in all of profound history. Professional observatories had the impact sites calculated down to the minute, but amateur images captured around the world were picking up something the powerful big scopes quietly missed. Faint fragments trailing the main chain, pieces too dim for the automated surveys to detect, but profoundly visible to patient observers willing to stack dozens of exposures by hand. Those smaller fragments turned out to be profoundly real. Some of them struck Jupiter hours after the main impacts, creating secondary fireballs that no one had predicted. Then there is the quiet explosion of Comet 17P Holmes in October 2007. This normally faint comet suddenly exploded in brightness, becoming profoundly visible to the unaided naked eye overnight. Amateur astronomers were the very first to capture the detailed images of the expanding debris cloud. They saw complex structures in the outburst, radial jets, and subtle spiral patterns that suggested the nucleus was rotating and throwing off material in organized streams. By the time the professional observatories swung their heavy, complex instruments toward Holmes, the initial, chaotic outburst had already elegantly evolved. The amateurs captured the early phase, the moment of maximum chaos, because they were already looking. The professionals were left scrambling to catch up. Why does this phenomenon quietly persist? How do backyard observers with consumer-grade equipment consistently beat the billion-dollar facilities to the profound punch? Part of the answer is simple coverage. There are thousands of dedicated amateur astronomers scattered across the globe, observing every clear night. They are not limited by telescope allocation committees or the slow process of grant funding. If something interesting appears, they simply point their scopes at it immediately. No proposals, no peer review, just pure, unadulterated curiosity driving them to capture whatever available photons they can. But there is a deeper, subtle factor at play. Professionals use highly standardized processing techniques that are meticulously designed to produce a clean, publishable, and repeatable image. These techniques demand aggressive noise reduction, flat field correction, and, crucially, artifact removal. Anything that does not look like a smooth, clean, cosmic object is filtered out. This is usually the correct approach. Most of the weird stuff in astronomical images really is just noise. But not always. Amateurs, especially those who process their own images, often skip this aggressive filtering. They use gentler stacking methods. They experiment with different sharpening techniques. They are not trying to produce final data for a journal article. They are simply trying to see what is actually there, noise and all. And sometimes, buried deep in that digital noise, is something profoundly real. Ray's images of 3I, Atlas, fit this quiet historical pattern perfectly. His stacking choices were unconventional. He used tight crops and moderate, then heavy, sharpening, rather than the heavy-handed noise reduction that professionals would apply immediately. That is precisely why the 5 points are visible in his images. A standard pipeline might have smoothed them away instantly as mere artifacts. Does that, in itself, mean they are real? Not necessarily. It only means they are persistent enough to survive his processing method, which is genuinely interesting, but not conclusive proof. The great danger with amateur profound discoveries is that they can also inadvertently introduce artifacts that look deeply compelling but are not actually there. Rolling shutter effects, subtle tracking errors, hot pixels that just happen to line up across multiple frames. All of these can create false structures that seem far too organized to be random. Professional processing removes these artifacts specifically to avoid making false, embarrassing, profound discoveries. So, we are left with a persistent tension. Amateurs sometimes see profound things that professionals miss, but they also sometimes see things that are not really there at all. The key, the only path to the quiet truth, is distinguishing between the two possibilities. And that requires careful analysis, independent verification, and quiet patience. In Ray's case, the verification is now arriving. Other amateur astronomers are pointing their own telescopes at 3i, Atlas, trying desperately to reproduce his strange results. Some claim to see the 5 points, others report seeing nothing unusual. Some even claim to see 6 points, or 4, or a continuous, fuzzy ring. The sheer variability suggests that the processing choices matter enormously. But even if the 5-point formation ultimately turns out to be an artifact, Ray's humble image has already accomplished something profoundly valuable. It has forced the professional community to look much more carefully at 3i, Atlas. To check their own data for subtle structures they may have filtered out too aggressively. To quietly consider the genuine possibility that this interstellar visitor is far more complex than the initial observation suggested. And that is the true, quiet legacy of amateur astronomy. It does not replace the professional work, but it asks different, more daring questions. It looks at the data through fresh, unencumbered eyes, free from assumptions about what should or should not be there. Sometimes, those fresh eyes see artifacts, but sometimes, just often enough to keep us humble, they see the simple truth before anyone else does. And until the National Aeronautics and Space Administration finally releases its own calibrated images of 3i Atlas, Ray's footage remains the most detailed publicly available view of this strange object. Which means, for now, the amateurs are leading the quiet way, and the world is watching to see if they found something extraordinary or merely revealed how effortlessly we can be fooled by geometric patterns in the profound dark. It is a predictable pattern. Within mere hours of Ray's images going viral, the conspiracy channels, the dark, urgent corners of the immense internet, began to light up. They were, and remain, absolutely convinced that Ray's images show clear evidence of alien spacecraft, perhaps escort craft or scout probes. They are wrong, almost certainly wrong, but if you dismiss them entirely, you miss a crucial point. The 5-point formation is genuinely strange, even if it is not final evidence of extraterrestrial technology. The visual language of the conspiracy videos is instantly familiar. Dramatic, urgent music, excited, breathless narration, bright red circles meticulously drawn around the 5 distinct points. Claims that the National Aeronautics and Space Administration is actively covering up the profound evidence of intelligent monitoring. They offer facile comparisons to every vaguely shaped, blurry sighting in the last 50 years. It is a well-worn playbook. Much of what they claim to be showing is pure nonsense. Lens flares are mistaken for structured objects. Sharpening halos around the bright points are interpreted as some form of immense energy field or force field. Color gradients caused by simple sensor noise are rebranded as mysterious propulsion signatures. If you lack a fundamental understanding of how digital cameras process light, how stacking algorithms operate, or how optical artifacts are inevitably propagated through image enhancement, then Ray's footage can, indeed, be made to look like almost anything you desperately want it to be. But here is the central truth that must be quietly acknowledged. If you gently strip away the dramatic music and the breathless, speculative framework, some of the observations made by these theorists are not entirely baseless. They are noticing profoundly real features in the image that do not, at present, have straightforward, simple, accepted explanations. The perfect, even spacing of the 5 bright points, for example, bothers optical physicists just as much as it bothers the conspiracy theorists. Diffraction patterns can certainly create bright spots around a celestial object, but they typically appear as linear spikes or an isometric, symmetric bloom, not as 5 distinct, evenly distributed points arranged in a clean ring. Dust jets from a rotating comet can, indeed, create multiple bright regions in the coma. But the requirement for synchronized timing across 5 equidistant locations requires either a perfect geometric alignment of the surface vents or some unknown, organizing force that is subtly structuring the entire pattern. Then there is the issue of flicker synchronization. Several independent observers who have meticulously processed Ray's raw frames report that the 5 points appear to brighten and dim together, rather than doing so randomly. This coordinated luminosity variance is precisely the kind of subtle detail that fuels the conspiracy channels, who immediately jump to the conclusion of artificial control. But it is also precisely the kind of detail that suggests a coherent, real physical process is taking place, even if that process is entirely natural. One possible, profound explanation involves rapidly rotating dust structures. If the comet nucleus has a specific, non-spherical shape, perhaps it is elongated or flattened, and it is rotating quickly, the dust thrown off the surface could form temporary shells or rings that persist for a few minutes before dispersing. As the nucleus rotates, these delicate shells might catch the sunlight at repeating, synchronized intervals, which creates the profound appearance of synchronized flashing. It is speculative, but it is purely physics. It is not science fiction. Another possibility, as we explored before, involves the subtle electric fields in the coma. Comets traveling through the solar wind inevitably accumulate an electric charge. That charge has the power to organize dust particles into distinct patterns, pulling them into delicate filaments or concentrating them at specific, stable distances from the nucleus. Laboratory experiments have definitively shown that charged dust can spontaneously self-organize into surprisingly regular, complex structures. If 3I Atlas is electrically active, and interstellar objects might be more active due to their high relative velocity through space, those powerful electric fields could, in fact, create the geometric patterns that Ray's images seem to show. The conspiracy channels, naturally, do not mention electric fields or the complex, trajectorial dust orbits. They leap immediately to the conclusion of extraterrestrial surveillance. But the underlying observation, the core idea that the pattern looks organized, is not crazy. It is a perfectly reasonable, human response to data that genuinely appears structured. The essential failure of the conspiracy theorists is in assuming that structure automatically implies intelligence. Humans are inherently pattern recognition machines. We see faces in clouds, pyramids on Mars, and subtle messages in simple white noise. Our brains evolved to detect agency, to automatically assume that an organized pattern means someone organized them. This profound instinct is what kept our ancestors alive. A rustling of grass might mean a predator, but this same instinct fundamentally leads us astray when we try to analyze cosmic phenomena. The vast universe produces symmetry constantly, and it does so without any intelligence involved. Snowflakes are hexagonal because of the simple molecular structure of ice. not because tiny architects are carefully designing them. Saturn's immense rings are layered and banded because of orbital resonances, not because someone painstakingly arranged them that way. Spiral galaxies form their elegant, winding arms through the simple physics of gravity, not intentional engineering, but symmetry is compelling. When we see it, especially in an unexpected cosmic context, like an interstellar object, that primal instinct goes immediately into overdrive. So, the conspiracy channels are wrong about the aliens, but they are not wrong about the strangeness. The 5-point formation, if it turns out to be real and not merely a subtle artifact of processing, represents something that simply does not fit easily into our existing comet models. That is absolutely worth investigating. That is worth taking seriously. The only problem is that taking it seriously means doing the slow, boring, painstaking work, running complex simulations, testing alternative, mundane hypotheses, comparing the raw data to known cometary behavior, and, most importantly, quietly waiting for better observations. Conspiracy theorists do not possess the patience for that kind of slow, methodical work. They want the answer now, and they want it to be profoundly dramatic. Scientists, meanwhile, are deeply comfortable with uncertainty. They know that the overwhelming majority of anomalies turn out to have completely mundane, natural explanations. They have witnessed too many impossible observations quietly collapse under rigorous scrutiny, so they approach Ray's images with caution, always looking for the simplest explanation first, before they even begin to consider the exotic alternatives. That quiet caution is profoundly appropriate, but it can also lead to premature dismissal. If the 5 points are immediately categorized as processing artifacts without careful, rigorous analysis, we might miss a profound, genuine discovery about how interstellar objects actually behave. We might overlook a real physical process that could teach us something entirely new about dust dynamics, or rotation states, or the coherent structures that form in an active coma. The truth, as usual, is likely a complex combination. The 5 points are probably a subtle mix of real, physical features and subtle processing artifacts. Some of what Ray captured is likely genuine jets or dust concentrations that truly exist in the comet's actual coma, and some of it is likely digital enhancement bright spots, amplified by stacking and sharpening until they look far more defined than they really are. Separating those two components requires one thing: better, independent data. Until the National Aeronautics and Space Administration releases professional, calibrated observations, until multiple independent teams analyze 3I Atlas with their calibrated instruments, we will not know for certain what is real and what is mere illusion. But the conspiracy channels have, inadvertently, done one useful thing. They have kept the public attention fiercely focused on the anomaly. They have ensured that when the National Aeronautics and Space Administration finally releases its data, millions of people will be watching. And if there is anything unusual in those images, anything that remotely resembles the subtle patterns Ray captured, the quiet pressure will be on the scientists to provide a profound, complete explanation. So, yes, the conspiracy theorists are profoundly wrong, but they are asking the most fundamental, right question. What is actually out there, and why, truly, does it look like that? Even if the answer turns out to be boringly natural, the question is always worth the asking, because every now and then, just often enough to keep us humble. The universe surprises us with something that, according to our current models, simply should not exist. And we will not know if 3I Atlas is one of those profound surprises until someone looks at it properly. 3 mysterious interstellar visitors have quietly entered the inner sanctum of our solar system in the past 8 years. 3 objects that originated somewhere else, that formed around a distant, long-dead star, and that traveled through the crushing void between stellar systems for potentially millions of years before the subtle pull of our sun's gravity caught them and bent their trajectory through our cosmic neighborhood. Each one has been profoundly strange in its own, unique way, and if you line them up, a subtle, disquieting pattern begins to emerge. Not a pattern that proves anything, but a pattern that forces you to wonder if we have been thinking about interstellar space in a fundamentally incorrect way. First, in October 2017, 1I Oumuamua was spotted streaking through the inner solar system, already past its closest approach to the distant sun and quietly heading back out toward the crushing expanse of interstellar space. The name means scout or messenger in Hawaiian, and it was the very first confirmed interstellar object ever detected passing through our system. Almost immediately, it was profoundly weird. Its orbit was subtly wrong. Oumuamua was observed to be accelerating slightly as it moved away from the sun, more than gravity alone could possibly explain. Not by much, just a tiny excess velocity that showed up in the tracking data, but it was undeniably there, and it should not have been. Comets accelerate due to outgassing jets of vaporized ice, pushing them like tiny rocket engines. But Oumuamua showed no visible coma, no tail, no evidence of any visible activity. It was too small and moving too fast for detailed, close-up imaging, but spectroscopy revealed a dark, reddish surface, far more like an asteroid than an active comet. So, what profound, invisible force was pushing it? Theories multiplied. Perhaps it was outgassing something entirely exotic, a volatile substance that simply does not produce a visible coma, frozen nitrogen, or frozen hydrogen materials we would not expect in our own solar system. But that might be perfectly common wherever Oumuamua originated, or perhaps its shape was profoundly strange, elongated like a massive cigar or flattened like a pancake, so that the subtle radiation pressure from the sunlight was pushing it far more efficiently than it would a typical spherical space rock. One highly respected Harvard astronomer went further. He seriously suggested it could be artificial, a light sail, a probe, an artifact of technology built by another civilization and sent drifting through the vast, silent galaxy. Most scientists quietly rejected the artificial hypothesis, not because the possibility of technology in the cosmos is impossible, but because the available evidence did not strictly require it. Oumuamua could still be explained by purely natural processes, provided you made reasonable assumptions about its strange composition and bizarre shape. Jumping straight to the conclusion of aliens was seen as premature, but the fact that a respected scientist even published the idea tells you how profoundly strange Oumuamua truly was. It forced astronomers to quietly consider possibilities they would normally dismiss out of hand. Then, in August 2019, 2I Borisov appeared, and it was the opposite of Oumuamua in almost every single way. It possessed a bright, obvious coma, a long, beautiful tail. Spectroscopy showed familiar cometary molecules, carbon monoxide and water vapor, exactly what you would expect from an icy body heated by the sun. Borisov looked normal. It acted normal. If you did not know it originated from another star system, you would simply think it was just another comet from our own Oort cloud. The quiet relief among astronomers was palpable. See, the general thought went, interstellar objects are not that weird. They are just comets and asteroids that happen to wander in from somewhere else. But even Borisov had its own subtle quirks. Its carbon monoxide concentration was extremely high, far higher than typical comets from our own system. Its dust production rate varied wildly and chaotically, spiking and dropping without any obvious, predictable pattern. And its nucleus appeared to be slowly fragmenting, shedding pieces as it rounded the sun, behavior that suggested it was structurally weak, held together by ice that was sublimating rapidly. Still, Borisov was understandable. It fit within the general range of behaviors we have observed from solar system comets. It was exotic, yes, but not profoundly alien in the sense that makes people nervous. Now, we have 3I Atlas, and it is splitting the difference between its two predecessors in the strangest way imaginable. Like Oumuamua, Atlas shows features that simply do not fit the standard models: the 5-point geometric formation, the rapid rotation or precession, the strange, shifting structures in the coma that Ray's images seem to capture. But unlike Oumuamua, Atlas is clearly active. It possesses a visible coma. It is throwing off dust and probably gas. Optically speaking, it is behaving exactly like a comet should. Yet, like Borisov, Atlas seems to be fragmenting or undergoing profound structural changes. The dark ridges in the coma, the possible shadowing effects, the way the bright core shifts position between frames. These all suggest that something is actively happening to the nucleus, a process that is altering its shape or its surface properties in real time. But neither Oumuamua nor Borisov showed symmetric patterns like the 5 points. Neither one produced imagery that made people immediately think of a formation or an escort. That is new. That is unique to Atlas. So, what, fundamentally, does it mean? One possibility is simple diversity. 3 objects is still a tiny number, statistically meaningless. If we wait another decade and detect 30 interstellar visitors, we might find that each one is profoundly weird in its own way, and the weirdness simply averages out to a full spectrum of complex, natural phenomena: elongated asteroids, fragmenting comets, objects with unusual rotation, states, all of it entirely natural, all of it explained by the chaotic processes that form and eject material from other star systems. Another possibility is selection bias. We only notice interstellar objects that are already unusual. Oumuamua was spotted because it was moving fast on a strange trajectory. Borisov was spotted because it had an obvious, immense tail. Atlas was spotted because of its profound brightness and activity. Hundreds of boring, dark interstellar rocks might pass through our system every year, silent and invisible, and we would never know. We are building a catalogue of only the profoundly weird ones, because those are the only ones we have the capacity to see. But there is a third possibility that is far harder to dismiss. Maybe interstellar objects really are more profoundly varied than our own solar system objects, because they originate from far more varied environments. Our solar system formed from a single molecular cloud around a single star. Everything here shares a common origin, the same initial composition, the same formation, temperature, and pressure, the same bombardment history. Interstellar objects, however, come from everywhere, different stars, different nebula, different epochs in galactic history. An object that formed around a hot, blue giant would have a completely different thermal history than one that formed around a cool, dim red dwarf. If this is true, if interstellar space is profoundly full of objects shaped by wildly different processes, then we should, in fact, expect every single visitor to surprise us. Not because they are artificial or anomalous, but because they are showing us what happens in environments we have never sampled. 3I Atlas might have formed in a system with extreme tidal forces, creating internal structures or layering that naturally produces symmetric outgassing patterns. Or it might come from a debris disk around a binary star, tumbling chaotically for eons until its rotation state locked into a complex precession. Or it could simply be a fragment from a larger body that shattered in a distant collision, and we are simply seeing the geometric remnants of that fracture. All of these are entirely natural explanations. None require intelligence or technology, but all of them push the very boundaries of what we thought interstellar objects could look like. And that is the quiet, profound significance of comparing Atlas to its predecessors. We are not merely cataloguing weird rocks. We are starting to map the incredible diversity of planetary materials across the vast galaxy. Every interstellar visitor is a free sample from a star system we will never reach. A messenger carrying information about conditions light years away. Oumuamua taught us that some objects accelerate mysteriously. Borisov taught us that some have extreme compositions. And Atlas, if the 5-point formation quietly holds up, might teach us that some have geometric structures we have simply never seen before. Or it might teach us nothing except how easy it is to misinterpret amateur images of distant objects. But we will not know until we look. Until the National Aeronautics and Space Administration points its best instruments at 3I Atlas and shows us what is truly there, hidden behind the blur and noise of Ray's backyard telescope. And whatever that reveals, it will be one more profound data point, one more piece of the vast cosmic puzzle. 3 visitors down, thousands more to come if we simply keep watching the sky. While the world's quiet attention has been fiercely focused on the profound mystery of 3I Atlas, something strange and utterly unexpected was happening much closer to our home. Something that might, in fact, explain why we are seeing organized, geometric patterns where they should not exist, or something that might simply prove that the universe possesses a mischievous sense of humor, a profound love of confounding our expectations. On November 6, 2025, the Deep Space Network picked up an unusual radio burst emanating from the distant sun. The event was not unusual because it was overwhelmingly loud. Solar radio emissions occur constantly. The sun is a massive, turbulent ball of plasma, with immense magnetic fields that are constantly twisting and snapping. And every time a magnetic field line breaks and then violently reconnects, it accelerates charged particles that emit radio waves. Solar astronomers have neatly classified these events into categories Type 3 bursts, Type 2 bursts, based on their frequency and their precise duration. But this particular burst refused to fit neatly into any of the established categories. It began as a typical Type 3 event, a fast-drifting, high-frequency emission consistent with massive electron beams traveling outward through the Sun's thin corona. But then, it paused. The frequency stabilized instead of drifting lower, and over the next 17 minutes, it began to pulse, not randomly, not chaotically, but in a pattern that almost resolved itself into perfectly regular intervals. The data showed distinct peaks at roughly 3.2-minute intervals. Then, the pattern subtly shifted to 4.1 minutes. Then it quietly shifted back to 3-something. The fundamental periodicity was undeniably present, but it was slippery, like trying to catch a precise rhythm that constantly changes its tempo. Heliophysicists, the scientists who study the Sun, are profoundly divided by this data. Some argue that it is merely multiple overlapping bursts, coincidental timing, making it look like a real pattern. Solar activity is, after all, messy. Dozens of separate processes happen simultaneously. If you stare at the noise for long enough, you will eventually see rhythms that are not actually there. Others quietly point out that 3-minute to 4-minute periodicities are, in fact, real, known features of solar oscillations. The Sun rings like an immense bell, vibrating at specific, complex frequencies determined by its internal structure. Those oscillations can indeed modulate radio emissions, creating quasi-periodic patterns in the available data. Not perfectly regular, because the Sun is turbulent, but consistent enough to show up under careful analysis. But what truly bothers people is the sheer coincidence of the timing. This strange, pulsing burst happened precisely while 3I Atlas was making its closest approach to the Sun. While amateur astronomers around the globe were pointing their delicate telescopes at the comet, capturing the very images that might show geometric patterns, while the National Aeronautics and Space Administration was quietly preparing to release its official, long-awaited observations. Correlation does not, of course, imply causation. The Sun does not care about comets. Solar radio bursts do not respond to icy rocks that are millions of kilometers away. The timing is, most likely, a coincidence. But here is precisely why this profound solar event matters for the mystery of Atlas. Solar radio emissions can subtly interfere with observations, not directly, by blocking the light or scrambling the telescopes, but indirectly, by profoundly affecting the space environment that surrounds the comet. The solar wind carries magnetic fields and a flux of charged particles. When those fields fluctuate, when the particle density spikes, comets react. Their comas compress, dust tails shift, jets activate or shut down entirely in response to the changing pressure. If the solar radio burst coincided with unusually turbulent solar wind conditions, then 3I Atlas might simply be responding to those profound conditions. The 5-point pattern Ray captured might be the complex result of the comet's coma reacting to pressure waves in the solar wind. Dust might be concentrating at specific, stable distances where the incoming and outgoing flows exactly balance. Plasma structures might be forming at the magnetic field boundaries. This kind of interaction has been observed before. Comet Ison in 2013 showed strange coma structures as it approached the Sun, bright knots and filaments that appeared and disappeared entirely over a matter of hours. Later analysis revealed that those structures correlated perfectly with disturbances in the solar wind. The comet was being buffeted by space weather, and its coma was quietly showing the effects. Could the exact same thing be happening with Atlas? Could the 5 points be mere solar wind artifacts, temporary structures that only exist because the sun is doing something profoundly unusual right now? It is entirely possible, but it still does not fully explain the unsettling symmetry. Solar wind interactions with comets are typically asymmetric, creating tails that point away from the sun and bow shocks on the sunward side. Acquiring 5 evenly spaced bright points requires either a very specific alignment of the magnetic structures or, again, something profound about the comet itself that organizes the response symmetrically. And then there is the nagging periodicity problem. If the solar radio burst is pulsing every 3 minutes to 4 minutes, and the 5 points in Ray's images seem to flicker or subtly shift on similar timescales, is that merely coincidence, or is there a genuine, physical connection? The most likely explanation involves magnetic loops. The sun's corona is full of them, arches of hot plasma trapped along immense magnetic field lines. These loops can oscillate, bouncing like plucked strings at periods ranging from seconds to minutes. If one of these loops is oscillating at the right frequency, and if it is pointed directly toward the Earth, we would see the radio emission pulse in perfect time with the oscillation. But why would such an oscillation affect a comet millions of kilometers away? The radio waves themselves do not carry enough energy to influence dust or plasma. They are just electromagnetic radiation passing through space. Unless the radio burst is a symptom, not a primary cause, a visible signature of deeper solar wind disturbances that are simultaneously affecting both the sun's corona and 3I Atlas. In that case, the 3-minute to 4-minute periodicity would be a vital clue to the underlying oscillating process. Something in the solar wind is oscillating, creating subtle pressure waves that ripple outward, and both the sun's radio emission and the comet's coma are responding to the same driving force. Scientists are now meticulously combing through solar wind data from spacecraft like the Parker Solar Probe and Solar Orbiter, looking for subtle correlations. Preliminary results show elevated magnetic field variability during the period when Ray captured his images. Nothing extreme, no major flares or coronal mass ejections, just increased turbulence, small-scale fluctuations that would not normally be considered noteworthy. But in the profound, strange context of 3I Atlas, those subtle fluctuations might matter everything. They might be the profound, missing piece that explains why the 5 points appeared precisely when they did, why Ray's timing was perfect, even if he did not know it, or the solar activity might be entirely irrelevant, a cosmic red herring, the universe simply throwing noise into the data at exactly the wrong time, making it profoundly harder to separate real comet features from environmental effects. This is the eternal frustration of astronomy. You cannot control the experiment. You cannot simply turn off the sun's magnetic field to see what the comet does without it. You must observe what is there, when it is there, and try to patiently untangle cause from correlation after the fact. But here is the unsettling, final thought. If the sun can spontaneously produce quasi-periodic radio bursts that look almost organized, almost regular, then the universe is profoundly capable of creating misleading patterns, not just in fuzzy images of distant comets, but in the cold data we consider objective, frequency spectra, light curves, time series measurements. We trust instruments more than we trust our eyes. We know our brains see patterns in static, but instruments see patterns too. Sometimes, when the true signal and the subtle noise interact in just the right way. And sorting out which patterns mean something from which patterns are merely accidents of timing requires more than just good data. It requires context, history, and comparison to all other events. Right now, 3i Atlas is giving us a pattern we do not understand, during a period when the Sun is also giving us a pattern we do not fully understand. Maybe they are connected, maybe they are not. But until someone quietly figures it out, the possibility hangs there in the silent cosmos. Are we looking at a comet doing something genuinely strange? Or are we looking at a comet doing perfectly normal things, while the Sun adds profound confusion to the background? And if it is the latter, how many other cosmic mysteries are just the result of bad timing? Interesting objects observed during noisy moments, producing data that looks significant, but is, in fact, merely noise. That is the quiet question keeping solar physicists awake at night, right now. And the answer might matter far beyond the fate of 3i Atlas. You can never truly see gravity. You can feel its subtle, immense presence. Of course, when you trip and fall, or quietly watch an apple drop from a tree. But you cannot point a telescope at a distant object and measure its gravitational field directly. Gravity is not light. It does not emit photons. It is merely the curvature of space-time itself, invisible and profoundly silent. Except now, we can, in a manner of speaking, measure it, sort of. In May 2025, a dedicated research team at the National Institute of Standards and Technology announced a quiet, profound triumph. They had successfully built a portable device, roughly the size of a standard refrigerator, that can detect minute changes in gravitational field strength with absolutely unprecedented precision. We are talking about sub-millimeter resolution, the almost impossible ability to measure tiny variations in gravity that are caused by objects smaller than a single grain of sand. The core technology is not new in its basic concept. Atom interferometry has existed for decades. The basic idea is simple and elegant. You take a cloud of ultra-cold atoms, split them into two separate paths using powerful laser pulses, and allow them to travel through slightly different gravitational environments. Then, you bring them back together and meticulously watch how they interfere with each other. The resulting interference pattern precisely tells you about the gravitational field difference between the two paths. What is new is the sheer, stunning precision. Previous atom interferometers could certainly detect gravity variations, but they required hours of slow integration time and meticulously controlled laboratory environments. This new device works in mere minutes, even in field conditions, with an accuracy that is now approaching the theoretical limits of what is possible. Why does this matter profoundly for astronomy? Because gravitational field mapping could revolutionize how we quietly study the small, icy bodies in the vastness of space. Right now, when we want to know the precise mass distribution of a comet or an asteroid, we must send a spacecraft close enough to measure how its trajectory subtly bends. That is precisely how we learned that Comet 67P possesses a profoundly strange density distribution, lighter than expected in some regions, suggesting internal cavities or voids. But achieving that data required the Rosetta mission, years of meticulous planning, and billions of dollars. Imagine, instead, quietly pointing a quantum gravimeter at 3I Atlas and measuring its gravitational signature from Earth. You could not map the entire object, not from this immense distance, but you could potentially detect subtle asymmetries, dense mass concentrations, and regions that pull harder than the surrounding areas. If the 5-point formation is truly real, if there really are distinct, separate objects orbiting the nucleus, a sensitive enough gravimeter should see them. Each object would possess its own tiny gravitational signature, minuscule perturbations in the field that shift as they orbit. The pattern would be unmistakable. Of course, there is one major, insurmountable problem right now. 3I Atlas is millions of kilometers away. Its total mass is perhaps a few billion tons, which sounds like a lot until you realize that is nothing compared to Earth's nearly 6 sextillion tons. The gravitational pull from Atlas at this immense distance is vanishingly, infinitesimally small, completely swamped by the local gravity from the Moon, the Sun, and even passing trucks on the highway near the detector. But the researchers claim they are quietly working on it. The next generation device, planned for deployment in 2027, will operate in space initially aboard the International Space Station and then possibly on a dedicated satellite, away from the overwhelming gravitational noise of the Earth. The subtle sensitivity of the instrument jumps by orders of magnitude, and here is where it becomes profoundly interesting for interstellar objects. If we had a quantum gravimeter already in space when the next visitor arrives, we could map its internal structure without ever sending a probe. We could detect fragments, measure its subtle spin dynamics, and identify hidden mass concentrations that might explain any future unusual behavior. For 3I Atlas specifically, the timing is profoundly frustrating. The core technology exists, but not in a configuration that can observe the object while it is still close enough to precisely measure. By the time a space-based gravimeter is fully operational, Atlas will be years past perihelion, far too faint and too distant for detailed study, unless someone, perhaps the National Aeronautics and Space Administration, fast-tracks a mission. The agency maintains a rapid response program for targets of profound opportunity, with emergency funding that can be released when something scientifically valuable suddenly appears. 3I Atlas might just qualify. If the 5-point formation quietly holds up under professional scrutiny, if the agency's upcoming data release shows anything genuinely anomalous, there could be the political will to rush a gravimetric satellite into a precise position. It would not need to be fancy. A small spacecraft, a single instrument, a 6-month development and launch timeline if they really pushed it. Point it at Atlas, take the precise measurements, and see if the gravity field shows structure consistent with the subtle optical observations. But that is all speculation right now. The quantum gravimeter breakthrough is merely a tool in the vast cosmic toolbox, quietly waiting for its first profound application. The broader implication, however, is about hidden structure. We have been quietly studying the cosmos with electromagnetic radiation for centuries. Light in all its forms, from long radio waves to powerful gamma rays. It has given us an incredible view of the vast universe, but it is fundamentally incomplete. Electromagnetic radiation tells you about surfaces, about emitting regions, about hot plasma and glowing dust. It does not tell you what is truly inside. It does not reveal internal structure unless that structure happens to emit or absorb light differently than its surroundings. Gravity does not care about surfaces. It responds to mass, wherever that mass happens to be. A dense core buried deep inside a fluffy coma would be utterly invisible to a telescope, but profoundly obvious to a gravimeter. A hollow structure, like a fragmented nucleus, held together by loose rubble, would possess a completely different gravitational signature than a solid rock of the exact same size. This is why planetary scientists are so deeply excited about the potential of the technology. It means we can finally peer inside comets, asteroids, and moons, anything with enough mass to generate a measurable gravity field, and see how they are actually built. And if 3I Atlas truly does have something profoundly strange going on, if there is hidden structure organizing the 5 points or driving the unusual rotation, gravity will inevitably reveal it. Not by showing us pretty pictures, but by showing us the profound distribution of mass, where it is, how it is distributed, and how it moves. The conspiracy theorists would have a quiet field day if someone pointed a quantum gravimeter at Atlas and discovered 5 distinct gravitational sources orbiting the nucleus. They would claim vindication, proof of artificial objects, technology quietly monitoring the comet. But the reality would likely be far more mundane, yet still profound. 5 fragments, dense chunks of ice or rock that broke off during a close stellar encounter millions of years ago and have been loosely orbiting the main body ever since, held together by minuscule gravity, gradually spreading apart, but still close enough to appear as a formation in amateur images. That would be exotic, unprecedented for an interstellar object, but entirely, beautifully natural. Or maybe the gravimeter would show nothing at all. One smooth gravitational field, no substructure, quietly confirming that the 5 points are mere optical artifacts, dust concentration patterns, diffraction effects, or processing illusions. Either way, we would finally know the truth. We would have an answer that does not depend on interpreting ambiguous images or arguing about pixel-level details in amateur astrophotography. That is the quiet promise of quantum gravimetry. Not that it will replace the telescope, but that it will add a new, profound dimension to our observation, a way to truly see the universe through the invisible lens of mass instead of the luminous lens of light. And if history is any guide, every single time we develop a new, profound way to observe the cosmos, we inevitably find things we never expected. Radio astronomy revealed pulsars and quasars. X-ray astronomy showed us the profound existence of black holes and neutron stars. Gravitational wave detectors are quietly catching stellar mergers that nobody predicted. So, what will quantum gravimetry ultimately reveal? What profound structures are hidden inside objects we thought we already understood? What surprises are quietly waiting in the mass distributions of comets and asteroids and interstellar visitors? We are about to find out. The core technology exists. The devices are being built. Within a decade, gravimetric mapping will be as routine as taking a spectrum. And when someone finally points one of these instruments at an interstellar object, when we get our first gravitational map of something that formed around another star, we might quietly discover that 3I Atlas was merely the beginning. That weirdness is, in fact, the norm out there. That every single object carries hidden secrets in its internal structure, invisible to light, but quietly written in the fundamental language of gravity. Or we might simply find that interstellar objects are boringly normal inside, and all the profound strangeness is merely on the surface, in the coma, in the chaotic way ice sublimates and dust flows. But we will not know until we look. And now, finally, we possess a way to look that goes profoundly beyond the simple limits of light. In August 2023, a specialized machine learning algorithm, diligently combing through an immense archive of data from the Transiting Exoplanet Survey satellite, flagged something that, according to our deepest models, should not exist: a planet with an orbital eccentricity of 0.973. To truly put that astonishing number into human perspective, consider the world we know. Earth's orbit around the Sun is nearly a perfect circle, with a minuscule eccentricity of 0.017. Mercury, the most eccentric planet in our local solar system, clocks in at a modest 0.206. Even Pluto, out in the frozen, lonely darkness, only reaches 0.25. An eccentricity of 0.973 means this planet's orbit is barely closed. It is an immensely elongated ellipse, so drastically stretched that at its farthest point from its parent star, the planet is almost 90 times more distant than at its closest approach. It spends the overwhelming majority of its time in the frozen outer reaches of its system, then violently screams inward for a brief, scorching perihelion passage before swinging back out into the profound dark. No planet should, by all rights, survive such an orbit. The immense tidal forces during the close approach to the star should rip it violently apart. The thermal stress from going between near absolute zero temperatures and star-grazing heat should fracture its entire crust, boil away its atmosphere, and utterly destroy any structural integrity it possesses. Yet, the transit data is utterly clear. The planet exists. It is roughly the size of Neptune, and it is faithfully completing this insane orbit every 412 Earth days. Astronomers immediately began proposing explanations. The most obvious is a three-body interaction. If this planet shares its system with another massive world, gravitational kicks during close approaches could pump up the eccentricity over the course of millions of years. Eventually, one planet gets violently flung into an extreme orbit, while the other settles into something far more stable. Or perhaps there is a stellar companion, a distant brown dwarf, or a faint, hidden star we have not detected yet, that is subtly perturbing the planet's orbit every few thousand years, preventing it from circularizing. Or the planet could be the sole, fragile survivor of a catastrophic system-wide encounter. Its parent star might have had a close encounter with another star, violently scrambling the orbits of everything in the system. Most planets would have been ejected entirely, flung into interstellar space. This one barely hung on, left in an orbit that is technically bound, but only just. The artificial intelligence that found it was not deliberately looking for impossible planets. It was meticulously trained on thousands of known exoplanets, learning the subtle, predictable patterns of normal transit signatures. Then, it searched through the vast archival data, looking for anything that matched those patterns, flagging the best candidates for human review. This planet showed up in the flagged list with a clear note: high confidence detection. Anomalous parameters recommend verification. And when the human astronomers looked at the raw data themselves, they quietly confirmed it. The transits are real. The orbital solution is solid. The eccentricity is actually 0.973, not a processing error or a subtle mathematical misfit. So now we have a planet that profoundly exists but should not, discovered by a tireless algorithm that noticed something human analysts had missed for years. The data had been public for a long time. Anyone could have found it. But nobody did, because nobody was specifically looking for something that extreme. This is quietly becoming a pattern. Artificial intelligence systems are finding profound anomalies in astronomical data faster than humans can possibly keep up. Not because the algorithms are inherently smarter, but because they are utterly tireless. They can check every single object in a vast catalogue against every single possible model, flagging the outliers without ever getting bored or automatically assuming that weird data must be wrong. And here is where it quietly connects to 3I Atlas. The 5-point formation is a profound outlier. It simply does not fit the standard Comet models. If you trained an artificial intelligence on thousands of Comet images and asked it to classify Ray's footage, it would almost certainly flag it as anomalous. But anomalous does not mean impossible. This exoplanet profoundly proves that. It is anomalous as hell, but it exists. It is quietly orbiting a real star with a real, measurable period. The fact that we did not predict such orbits does not make them impossible. It simply means our existing models were profoundly incomplete. The same profound truth might be applicable to 3I Atlas. Maybe interstellar comets can have symmetric jet patterns that solar system comets simply do not show. Maybe objects from other stellar environments develop intricate structures we have never seen before because they formed under profoundly different conditions. The exoplanet also highlights something crucial about what scientists call edge cases. Statistically, the overwhelming majority of objects are normal. Most planets have perfectly reasonable eccentricities. Most comets have messy, chaotic, asymmetric comas. The bell curve is fat in the middle, but the far tails of the distribution extend farther than we usually dare to imagine. There are planets with 0.97 eccentricity. There might be comets with a perfect 5-fold symmetric jet pattern. These objects are undeniably rare, but rare does not mean non-existent. If we observe 1,000 comets, and 999 of them display typical, chaotic structures, we will build our entire model based on those 999. And when the 1,000th comet quietly shows up with something profoundly different, our first human instinct will be to instantly dismiss it as an artifact or a measurement error. But sometimes the 1,000th comet is real. Sometimes the outlier is quietly teaching us something that the typical cases simply cannot. This is what edge case cosmology means. The rare objects, the anomalies, the subtle things that barely fit within our physical laws. These are the objects that force us to quietly expand our understanding. They show us the very limits of what is physically possible. They map the boundaries of the phase space that normal objects never explore. 3I Atlas might be an edge case, an interstellar comet with properties that are rare but not impossible, shaped by a formation environment we do not possess in our own solar system, carrying structures or behaviors that only show up in 1 out of every 1,000 visitors. Or it might be a perfectly normal comet that we are simply observing in a profoundly unusual way, through the lens of amateur processing that makes it look far more exotic than it truly is. But the discovery of the impossible exoplanet should make us profoundly cautious about dismissing the strange too quickly. The universe has a quiet habit of producing things we did not predict. And every time we declare something impossible, nature finds an elegant way to prove us wrong. So, when the National Aeronautics and Space Administration finally releases its 3I Atlas data, when professional images finally show what is really there, we should be quietly prepared for the genuine possibility that it is, in fact, genuinely weird, not artificial, not alien, but weird enough to fundamentally require new explanations. Because if a planet can possess 0.97 eccentricity, if artificial intelligence can find it hiding in plain sight in public data, then maybe a comet can possess 5 bright points arranged in a perfect ring. Maybe that is just what happens sometimes, when objects form under the right conditions and get kicked into interstellar space with the precise spin state. Or maybe it is all subtle artifacts and wishful thinking, but we will not know until we look with better instruments than Ray's backyard telescope. And that is the lesson from the impossible exoplanet. Look carefully, trust the data, and never assume that anomalies are always errors. Sometimes they are profound discoveries. In September 2025, the National Ignition Facility in California announced a quiet, profound triumph. They had successfully sustained a net positive fusion reaction for 32 full seconds. Not the brief, fleeting microsecond pulses they had achieved in previous, frustrating experiments. Not the barely break-even results that required perfect, unique conditions and multiple attempts, but 32 full seconds of continuous, self-sustaining fusion, producing more energy than it quietly consumed. The plasma temperature during those 32 seconds reached an astonishing 150 million degrees Celsius, 10 times hotter than the very core of our sun. Inside a powerful magnetic bottle barely larger than a simple beach ball, hydrogen nuclei were moving so rapidly, colliding so violently, that they finally overcame the immense electrostatic repulsion and fused into helium, releasing enormous amounts of raw energy. Keeping that intensely hot plasma stable for even a single second is an engineering miracle. The precise magnetic fields that contain it have to be shaped with exquisite precision. Any subtle wobble, any instability whatsoever, and the plasma instantly touches the chamber wall, which instantly quenches the fusion reaction. It is, as the physicists quietly joke, like balancing a perfectly spinning top on the point of a needle, while the top itself is on fire and made of the sun's interior. For 32 seconds, they held it. The plasma remained perfectly confined. The fusion continued, and when the reaction finally destabilized, not from equipment failure but from a deliberate shutdown, the data showed something utterly remarkable. The plasma had quietly self-organized into stable structures, filaments, bright regions rotating around the confinement axis, in a pattern that looked almost geometric. Not perfectly regular, of course, but far more ordered than random turbulence should possibly produce. This phenomenon is not entirely surprising to the plasma physicists. Hot plasma behaves in counterintuitive, profound ways. It spontaneously forms coherent structures, magnetic islands, and helical filaments because the charged particles follow the immense magnetic field lines, and the field lines inevitably interact with each other. What looks like fundamental chaos on short timescales can display surprising, complex order when you zoom out and watch the quiet patterns evolve. But here is precisely where it becomes profoundly relevant to 3I Atlas. The 5-point formation that everyone is quietly arguing about looks profoundly structured. Too structured, the critics insist, to be entirely natural. But if fusion plasma, the most turbulent, chaotic environment humans can possibly create, spontaneously develops geometric patterns, then maybe comet plasma can, too. Comet comas are profoundly full of plasma ionized gases, electrically charged dust particles. All of it is quietly moving through the sun's immense magnetic field, constantly interacting with the solar wind. The physics is certainly different from a fusion reactor. The temperatures are far lower, the densities are minuscule by comparison, but the basic principles of magnetohydrodynamics are essentially the same. Charged particles in magnetic fields can, and often do, self-organize. There is a natural phenomenon called plasma instability that is known to create regular patterns. One type, the Kelvin-Helmholtz instability, forms when two plasma flows move past each other at profoundly different speeds. The boundary between them develops ripples, then waves, then distinct, stable vortices that can appear as bright, luminous knots when they are emitting light. If 3I Atlas is throwing off powerful jets from multiple vents, and those jets are interacting with the relentless solar wind, you could potentially get Kelvin-Helmholtz vortices forming at the interaction boundary. Space telescopes have, in fact, photographed similar structures in the magnetotails of planets. Bright plasma knots, arranged in surprisingly regular intervals, caused entirely by fluid dynamics. Could that simple, chaotic process explain the 5 bright points? Maybe, if the solar wind conditions were precisely right, if the comet's outgassing rate was in the perfect sweet spot, and if we are viewing the coma from a unique angle that shows the vortices edge on, it is physically possible. It requires a lot of ifs, but it is rooted in fundamental physics, not mere speculation. The fusion breakthrough also quietly highlights a profound truth about symmetry in nature. Engineers did not design the complex plasma filaments in the reactor. They deliberately tried to create a smooth, symmetric confinement field, but the plasma itself spontaneously decided where to form bright spots. The coherent structures emerged naturally from the core equations, from the simple, profound way that charged particles naturally behave under those extreme, turbulent conditions. Nature does this, quietly and constantly, everywhere. Sand dunes form repeating, parallel patterns. Cloud streets in the atmosphere line up in immense, parallel rows. Spiral galaxies develop arms that look undeniably designed, but are actually just the result of density waves in rotating disks. Humans see these profound patterns and instantly assume they were planned. We think someone carefully arranged the sand, organized the clouds, or built the entire galaxy. But they are entirely spontaneous. They arise from simple, core rules quietly playing out over and over until structure emerges from the fundamental chaos. The question for us, then, is whether 3I Atlas's 5 bright points fall into that profound category. Are they an emergent structure, plasma or dust self-organizing into a symmetric pattern because that is what the precise physics demands? Or are they subtle artifacts, processing glitches that raise stacking algorithm merely amplified into something that looks meaningful. The fusion data cannot directly answer that core question, but it does powerfully show that exotic, turbulent environments produce exotic, complex structures. And it quietly reminds us that the human judgment, too structured to be natural, is often profoundly wrong. Nature is full of structure, sometimes far more structure than any human engineering could ever hope to achieve. Consider the sun's own corona. It is threaded with immense magnetic loops, arches of plasma that connect the active regions on the solar surface. These loops look undeniably like carefully placed suspension cables on a massive bridge. They possess a defined, clean geometry, smooth curves, and endpoints that align perfectly with features in the photosphere below, but nobody built them. They formed simply because magnetic field lines minimize energy, quietly finding the shortest path between regions of opposite polarity. The entire structure is a consequence of fundamental physics, not of any intention. If we had discovered the sun without knowing what stars were, if we saw those coronal loops in a telescope, someone would probably argue they look artificial, too organized. They would say that no natural process could produce such clean geometry. They would be wrong, but their mistake would be entirely understandable. This is the profound, quiet trap we are in with 3i Atlas. We are pattern matching, trying to decide if the 5 bright points are too organized to be natural. But we do not yet possess a complete catalogue of what natural looks like for interstellar comets. We have, after all, only ever seen 3 of them total. That is simply not enough to establish what is typical. Maybe 5-fold symmetry is rare, but perfectly natural. Maybe it simply happens when comets with specific rotation rates and specific jet configurations interact with the intense solar wind at specific distances. Maybe we will see it again in the next interstellar visitor, and it will simply become another boring entry in the textbook of comet behavior. Or maybe it is unique to 3i Atlas, a one-time alignment of complex conditions that produce something we will never see again. The fusion reactor ran for 32 seconds and quietly taught us that plasma can hold together longer than we expected. It showed us subtle structures we did not anticipate, and it quietly proved that complex, high-energy systems do not always behave the way simple models predict. 3i Atlas is a complex, high-energy system, spinning through space, heated by the sun, and profoundly interacting with magnetic fields and particle flows. Maybe it is showing us subtle structures we did not anticipate because our cosmic models are still incomplete. Or maybe we are simply overthinking it entirely. Maybe the 5 points are mere lens flares and hot pixels, and in a month, everyone will have forgotten about Ray's images because the National Aeronautics and Space Administration's data will show a normal, boring comet. But 32 seconds of sustained fusion tells us to keep an open mind. Extreme environments do extreme things, and sometimes, just sometimes, the profoundly weird result is absolutely real. In January 2025, an amateur astronomer in Australia uploaded a meticulously processed image of a planetary nebula, a celestial structure that had been catalogued for decades. There was nothing particularly special about the nebula itself. It was the quiet remnant of a dying star surrounded by immense shells of ejected gas, glowing softly as ultraviolet light from the hot core ionized the material. But the amateur's processing revealed something nobody, professional or amateur, had ever noticed before. Dark rings, concentric shadows in the nebula's subtle structure, perfectly circular, evenly spaced, like ripples frozen in time. The image went instantly viral. People immediately called it proof of megastructures, Dyson rings, artificial shells built around the dying star to quietly harvest its remaining energy. The logic was familiar and immediate. The spacing is too perfect. Nature, they insisted, does not create concentric circles like that. Except nature does. Constantly. Within a single week, professional astronomers quietly released their formal analysis. The dark rings, they explained, were merely interference shadows. The nebula possessed multiple shells of ejected material, laid down sequentially during different phases of the star's death throes. Each shell was slightly denser than the surrounding gas. When light from the central star passed through these shells, it subtly diffracted and scattered, which created shadow patterns in the material behind. The circular appearance was simply geometry. The nebula happened to be oriented nearly face-on to the Earth. We were looking straight down the barrel of a fundamentally symmetric structure, so the shells appeared as perfect rings. If we viewed it from the side, we would see elongated lobes and irregular, chaotic filaments. Nothing mysterious at all. The even spacing of the rings came from stellar physics. Dying stars pulse with a profound, periodic variability. Each pulse ejects a shell of gas. The precise time between these pulses depends on the star's immense mass and composition, and for this particular star, the pulses happened at intervals that produced shells separated by roughly equal distances. No profound intelligence was required, no engineering, just a star doing what dying stars inevitably do, viewed from a coincidental angle that made it look far more organized than it truly was. But before that logical explanation emerged, the Dark Ring Nebula was the undisputed conspiracy theory of the month. Quiet, profound proof that advanced civilizations build shells around stars. Undeniable evidence that we are not alone. And here is the subtle, uncomfortable truth. The people who instinctively jumped to that profound conclusion were not, in a fundamental sense, being entirely irrational. They were simply looking at data that genuinely appeared structured and asking the most obvious human question. What could possibly make that perfect pattern? Their mistake was in stopping too soon. They saw the profound pattern, instinctively concluded it must be artificial, and did not dig deeper into whether purely natural processes could explain the perfect geometry. But the simple instinct to notice the pattern in the first place, that is not wrong. That is pattern recognition, doing exactly what it evolved to do. The profound lesson from the Dark Ring Nebula is that symmetry is a terrible, unreliable diagnostic for artificiality. The universe produces symmetric patterns constantly. Spherical stars, circular orbits, hexagonal crystals, spiral galaxies. None of these require intelligence. They are simply the elegant shapes that the fundamental physical laws favor. But humans are wired to see agency and symmetry. It is a cognitive shortcut that works well enough in our daily lives. If you see neat, parallel rows of objects, someone probably arranged them. If you see a perfect circular structure, someone probably built it. These quiet assumptions are right often enough that our brains default to them. The profound problem is when we apply that simple human intuition to cosmic phenomena. Space is immensely full of circles and spirals and symmetric structures, and almost none of them are artificial. They are the natural, inevitable consequence of rotation, gravity, pressure, and time. So, what does this profound understanding mean for 3I Atlas? If the 5-point formation is truly real, if professional observations quietly confirm that there really are bright spots arranged in a perfect ring around the nucleus, we must resist the intense, immediate urge to conclude it is artificial. The Dark Ring Nebula looked profoundly artificial, too, until someone actually did the precise physics. There are entirely natural explanations for symmetric patterns in a cometary coma, jets aligned by rotation, plasma structures organized by immense magnetic fields, dust concentrated at specific distances by the subtle balance of pressure. None of these are perfectly common, but common is not the same thing as possible. What we need now is not more enhanced images, not more sharpened, stacked, processed frames designed to bring out faint, blurry details. We need raw, hard observations from calibrated professional instruments. We need spectra showing what the bright spots are actually made of. We need time series photometry tracking precisely how they move. We need multi-wavelength imaging, revealing whether they emit in infrared or ultraviolet differently than the surrounding coma. The National Aeronautics and Space Administration's upcoming data release should provide some of that long-awaited information. The Hubble has been observing 3I Atlas. The James Webb Space Telescope might have pointed its lens at it. Ground-based observatories with advanced adaptive optics have probably captured images far superior to Ray's amateur shots. When that definitive data finally comes out, one of three profound things will happen. The first possibility: the 5 points simply vanish. The professional images show a normal comet with a predictable, asymmetric, chaotic coma. No geometric patterns, no bright ring. Ray's formation was merely an artifact of his processing, amplified by digital noise and profoundly misinterpreted by an internet desperate for a profound mystery. Everyone moves on. The conspiracy theories quietly fade. 3I Atlas becomes just another interstellar visitor, interesting for purely scientific reasons, but not for dramatic ones. The second possibility: the 5 points persist, but they come with a clear, undeniable natural explanation. Professional analysis shows they are natural jets, or plasma knots, or dust clumps, and the symmetric arrangement is undeniably rare, but still perfectly explicable. Papers get published, models get refined. Textbooks quietly add a small footnote about symmetric comet structures. The mystery resolves, not by disappearing, but by being quietly understood. The third, most profound possibility: the 5 points persist, and absolutely nobody can explain them. Professional images confirm the pattern. Spectra show the points have an unusual composition or strange emission properties. Time-lapse imaging reveals motion that does not fit any standard model. The scientific community splits between those who think we are fundamentally missing something about comet physics and those who suspect we are quietly seeing something unprecedented. That is the outcome that would genuinely change everything. Not because it would instantly prove artificiality, but because it would profoundly prove that our fundamental models are utterly incomplete. It would open up vast new research directions, quietly motivate new space missions, and force us to entirely reconsider what an interstellar object can actually be. And here is the absolute truth: we do not know which possibility is correct. Everyone has an opinion, Everyone believes they know whether Ray's images show something real or just subtle artifacts. But opinions do not matter, only data matters. The Dark Ring Nebula looked impossible until someone calculated the diffraction patterns. 3I Atlas looks strange until someone analyzes it properly. So, we wait. The National Aeronautics and Space Administration is reviewing its data. Scientists are quietly arguing in conference rooms and email threads. Peer reviewers are meticulously checking the calculations. And somewhere, presumably, someone is figuring out what is actually there. Maybe it is nothing. Maybe it is something. But the answer absolutely exists. The comet does not care what we think about it. It is simply out there, spinning through the inner solar system, doing whatever it does, utterly indifferent to the cameras pointed at it and the intense arguments happening on Earth. And when the real data finally comes out, when we see what professional instruments captured, we will finally know whether Ray stumbled onto a genuine, profound discovery or merely showed us how easy it is to quietly fool ourselves with subtle patterns in the immense dark. The most unnerving feature of the 3I Atlas saga is not the 5 points of light, but the profound absence of sound from the cosmos's primary narrator. The usual rhythm of disclosure has broken. The National Aeronautics and Space Administration, the agency that defined the narrative of the universe for half a century, is caught in a profound, conspicuous silence. And that silence, as we have discussed, is the most fertile ground for the propagation of profound, unsettling speculation. You must understand the immense psychological pressure on the agency. Avoiding another Oumuamua media frenzy has been established as a primary concern. That first interstellar object sparked immense, passionate debates that lasted for years. Astrophysicists argued fiercely over whether its non-gravitational acceleration was caused by a simple outgassing, the pressure of sunlight, or something else entirely. The term light sail entered the quiet conversation. A prominent, respected astronomer seriously proposed that it might be artificial. The media, predictably, ran wild with the speculation. Headlines screamed about alien probes. The National Aeronautics and Space Administration spent many exhausting months carefully walking back the intense speculation, presenting data and models that showed that natural explanations were likely sufficient. It was, by all accounts, an exhausting, distracting process. It set a powerful precedent. Interstellar objects trigger outsized, nervous reactions. If 3I Atlas shows even a subtle hint of strangeness, the agency knows exactly what is coming. They will be asked point blank if the 5-point formation is artificial. They will face intense pressure to immediately comment on the so-called escort hypothesis. Every single statement they make will be meticulously scrutinized. Every single image will be analyzed by thousands of armchair experts looking for the quiet proof of their preferred theory. It is, for the agency, a no-win situation. So, they delay. They triple-check the data. They meticulously prepare their public messaging. They attempt to quietly control the narrative before the narrative violently controls them. Public psychology also plays a profound, subtle role. Silence creates a vacuum, and that vacuum is instantly filled with a mixture of fear, wonder, and unfettered imagination. People quietly project their deepest hopes and their greatest anxieties onto the vast unknown. Some desperately want 3I Atlas to be something extraordinary. a first contact event, a probe from another civilization, final proof that we are not truly alone. Others want it to be profoundly mundane, just a comet, nothing to quietly worry about. Both groups are anxiously watching the National Aeronautics and Space Administration, looking for the validation of their chosen narrative. And the National Aeronautics and Space Administration, acutely aware of this dynamic, knows that whatever they say will satisfy some people and profoundly enrage others. If they declare the subtle anomalies are mere artifacts, the believers will instantly accuse them of a quiet cover-up. If they admit that the profound patterns are real but utterly unexplained, the skeptics will immediately demand answers and criticize them for not having any. There is no clean exit for the agency, only damage control. The plausible internal debate probably sounds something like this. One faction quietly argues, release the data now, even if it is incomplete. Transparency builds fundamental trust. Show what you have. Explain the uncertainties clearly, and let the entire scientific community quietly weigh in. The opposing faction argues for profound caution. Wait until you have definitive answers. Do not feed the speculation. Do not give the conspiracy theorists ammunition. Both positions are fundamentally defensible. Both have historical precedent. And both are likely represented in the quiet conference rooms at the Goddard Space Flight Center and the Jet Propulsion Laboratory, where scientists and administrators hash out the final strategy. The profound tension between institutional caution and scientific openness is absolutely real. It is not malicious, it is structural, but from the outside, it inevitably looks deeply suspicious. It looks, profoundly, like the agency is quietly hiding something. Testing artifacts versus real structure is a genuinely difficult, painstaking endeavor. You cannot simply look at an image and instantly know the truth. You need multiple, independent observations from different angles, different instruments, and at different times. You need to meticulously model how subtle artifacts propagate through the complex processing pipelines. You need to simulate what the object should look like under a wide range of assumptions and rigorously compare those simulations to what you actually see. If the simulations match perfectly, great. If they do not, you dig much deeper. You check for instrumental effects. You look for environmental factors like subtle scattered moonlight or profound atmospheric turbulence. You quietly rule out every single mundane explanation before you even begin to consider the exotic ones. This is the scientific method at its most painstaking, but it is also painfully slow. And when you are working with an object that is rapidly moving away from the sun, racing back into the dark void of interstellar space, time is a luxury you do not truly possess. Every single day, it gets dimmer. Every single week, it gets harder to observe with precision. The clock is relentlessly ticking, and the National Aeronautics and Space Administration knows it. The question for us, then, is simple. Are they seeing the same 5-point pattern? If the Hubble or the James Webb Space Telescope captured images showing smooth, asymmetric coma structure with no bright nodes, the entire mystery simply collapses. Ray's footage becomes a quiet, cautionary tale about amateur processing. But if their images show the same pattern, or worse, show it more clearly, then the entire game changes profoundly. Then the quiet discussion shifts from, is it real, to the profoundly harder question, what is it? And once you confirm the profound pattern exists, you are forced to explain it. And the explanations, as we have explored, require increasingly specific conditions, increasingly unlikely coincidences, until you reach a point where natural explanations start sounding just as contrived as the artificial ones. That is the quiet nightmare scenario for the National Aeronautics and Space Administration. Not that 3I Atlas is artificial, but that they cannot definitively prove that it is not, and speculation, like a weed, grows fiercely in that profound silence. Not just fringe theories, but serious, respected people asking serious, quiet questions. Let us return to the thought experiment. Let us assume, with quiet determination, that the escort hypothesis is, in fact, correct. That the 5 bright points are real, discrete objects in orbit around the comet's nucleus. We must now rigorously test this profound assumption against the cold, immutable laws of orbital mechanics. Astronomy, the science that gives us tangible options, often suggests that small fragments orbiting the comet after a prior breakup could create the precise pattern Ray observed. If the comet split violently at some point, ejecting material at specific velocities, some of that material could quietly enter orbit around the remaining nucleus. Orbital mechanics would then govern their predictable motion, depending on the immense mass distribution and the rotation of the nucleus. Stable orbits could, theoretically, exist. The fragments would quietly circle, maintaining relatively fixed positions in the rotating frame of reference. This is based on real, verifiable physics. Moons orbit planets, rings orbit gas giants. The same fundamental principles apply, even at the minuscule scales of a comet. But comet nuclei are tiny, fragile things. Their gravity is immensely weak. Keeping 5 discrete fragments in a stable orbit would require them to be physically very close, practically skimming the surface of the nucleus. And at those immensely close distances, the inevitable atmospheric drag from the vast, active coma would cause rapid orbital decay. The fragments would quietly spiral inward and violently crash into the nucleus. The stable configuration simply would not last. Unless, of course, the fragments were continuously replenished somehow, or unless the comet's coma is far less dense than our standard models predict. Orbital mechanics profoundly struggles to explain prolonged, multi-year stability. The profound dilemma deepens when we revisit the apparent orbital speed. If we assume the 5 points are objects circling the nucleus, based on the subtle shifts observed between Ray's frames, they would complete one full orbit roughly every 3 minutes to 5 minutes. That is an insanely fast orbital period. At that incredible speed, they would need to be very close to the nucleus, mere dozens of meters out, or the immense centrifugal force would simply fling them violently into deep space. Could fragments orbit a comet nucleus that quickly? Maybe, if the object is dense enough and the fragments are small enough. It is right at the very edge of plausibility, which means we must either accept an extremely unusual natural configuration, one where the fragments are being continuously generated and destroyed by the coma drag, a profound, rapid-fire cycle that happens to align with 5 specific points, or we must quietly consider the idea that the objects are being actively propelled. If they are propelled, the forces maintaining the perfect formation are non-gravitational. This is where the profound, speculative comparison to controlled attitude adjustment in aerospace engineering becomes relevant. A series of probes, or drones, maintaining their relative position to the nucleus via subtle, continuous thruster bursts. The thrust does not need to be strong, merely continuous and precisely controlled. It would create an exquisite geometry, a perfect, maintained perimeter. The movement Ray observed, the subtle shift in position over minutes, would not be orbital motion, but station keeping, the quiet, precise correction of position against the inevitable, chaotic perturbations from the comet's own jets and the pressure of the solar wind. This engineered explanation, though purely speculative, elegantly solves two major, profound problems that the natural explanations struggle with. First, it explains the uncanny symmetry. The formation would be symmetric because it was intentionally designed to be. Second, it explains the persistence and the speed of the motion. The objects persist because they are constantly correcting their position. They move quickly because they are not constrained by the weak, minuscule gravity of the comet. They are moving according to an internal, geometric plan. We are left with a cosmic choice. The natural explanation requires a cascade of highly improbable coincidences, a perfectly symmetric nucleus, a specific, unique viewing angle, continuous fragment generation, and profound, chaotic orbital mechanics that somehow conspire to create a clean, regular pattern. The artificial explanation requires only one immense, profound assumption: that intelligence exists and has passed through our system. The quiet tension remains. Without the high-resolution data that the National Aeronautics and Space Administration is currently withholding, we cannot perform the definitive test. We cannot resolve the geometry of the 5 points. We cannot distinguish between the subtle artifacts of image processing and the profound, physical reality of the phenomenon. The comet continues its quiet, indifferent journey, and the clock for definitive observation is rapidly running out. Ray's simple image, taken from a suburban backyard, has forced this immense, quiet contemplation. It has pushed us to the very edge of what is known, where the sheer complexity of natural chaos begins to look profoundly like deliberate design. The impossible exoplanet, with its profound eccentricity of 0.973, taught us a quiet, uncomfortable lesson. Anomalous does not mean impossible. It merely means that our models are incomplete. This is the essence of edge case cosmology, a profound recognition that the rare, extreme objects are the very ones that teach us the most fundamental truths about the universe. Statistically, the vast, overwhelming majority of objects in the cosmos are normal. Most planets orbit in simple, predictable circles. Most comets have messy, chaotic comas. The entire intellectual structure of modern astrophysics is built upon the 999 normal cases. We create complex, beautiful models that perfectly explain the average, but the truth, the quiet, profound, unyielding truth, is that the bell curve of normalcy extends its subtle tails farther than our comfort zone permits. There are objects out there, the 1000th comet, that defy the comfortable predictions. 3I Atlas might be one of those profound edge cases, an interstellar comet with properties so rare they have only now, on our third observation, appeared. Why would an interstellar object be more prone to profound, symmetric structures than a local comet? The key lies in the diversity of its origin. Our solar system comets share a common, single parentage. They all formed in roughly the same conditions, the same pressure, the same temperature gradient. They are, metaphorically, cousins. Interstellar objects, however, are drawn from the vast, chaotic galactic diaspora. They are formed around different types of stars, hot blue giants, cool red dwarfs, or in the turbulent, dense environments of star-forming nebulae. The thermal history of a comet from a different system could be vastly different from our own. Imagine a scenario where 3I Atlas formed in a profound binary star system. The continuous, immense gravitational pull from a second star would subject the comet's nucleus to intense, constant tidal forces. These forces might not violently break the comet apart, but they could induce a profound, rhythmic stress that subtly fractured the nucleus along regular, symmetric planes. This geological process could create a five-fold symmetry, a kind of natural, crystalline structure in the ice, where the most volatile material is channeled to 5 equidistant points on the surface. When the comet finally enters our solar system and is warmed by our sun, those 5 pre-stressed points would activate simultaneously, creating the precise 5-point geometric jet pattern that Ray observed. This explanation is still a complex tapestry of ifs, but it remains entirely within the realm of natural, albeit exotic, physics. It shows us a new way for nature to produce order. Another possibility lies in the dynamics of rotation. If Atlas was ejected from its home system with a very rapid spin rate, near the absolute limit of its structural integrity, any subsequent outgassing could easily cause it to enter a complex, stable, tumbling mode. This state, known as non-principal axis rotation, can look profoundly chaotic. But some complex fluid dynamics models suggest that specific spin states in an outgassing body can create regions of hydrodynamic stability within the coma. Dust particles, suspended between the weak gravity and the outward pressure of the gas, could quietly accumulate in these subtle, fixed zones, much like iron filings collecting around a magnet. If the rotation rate is precisely right, those stable zones could lock into a perfect geometric pattern. The symmetry is not engineered. It is a spontaneous, emergent property of the extreme fluid dynamics. The profound lesson of edge case cosmology is not that the universe is teeming with little green men. The profound lesson is that the universe is endlessly creative. Our physics is universal, but the initial conditions of formation are vastly different across the galaxy. The strange behavior of 3I Atlas is a gentle, cosmic reminder that we have only just begun to sample this immense diversity. It is a sample from the galactic junk drawer, and the contents are more surprising than our tidy, local models suggested. Whether the geometric formation is a simple processing artifact or a profound physical reality, the mystery itself has forced us to confront the limits of our knowledge. It has forced us to expand our mental model of what comet can mean. We are slowly mapping the boundary between the natural and the truly impossible. And until the professional, calibrated data is finally released, we must hold these profound, contradictory possibilities in quiet balance. The answer lies in the data, and the data is quietly waiting. Our journey through the mystery of 3I Atlas is as much a journey inward as it is a quiet search through the cosmos. It is a reflection on the profound, immutable human factor, our primal, irresistible urge to recognize patterns and to instantly ascribe meaning, or even agency, to subtle structure. The entire viral phenomenon of Ray's image began with the simple, profound fact that the pattern stopped people cold. Deep in some primal part of the human brain, symmetry instinctively means intelligence. Patterns instantly mean design. This is an ancient, fundamental survival mechanism. If our ancestors saw 3 rocks arranged in a precise line, or heard a repeating rhythm in the forest, survival often depended on the immediate assumption that someone or something intelligent placed them there. The universe, however, is beautifully indifferent to our survival instincts. It produces symmetry constantly. Spiral galaxies form their elegant arms through gravity. Sand dunes form regular, repeating patterns through simple wind dynamics. The five-fold symmetry of the comet's lights, statistically improbable as it may be, falls directly into this profound trap of human perception. We are simply wired to see faces in clouds. We are wired to see constellations in random stars. We see deliberate design in noise. This cognitive bias is powerfully amplified by the digital tools we use. Ray's meticulous process of stacking multiple frames to reduce the chaotic noise and bring out the faintest details is a powerful technique. But stacking, by its fundamental nature, is a filter that prefers order over chaos. When you layer multiple images on top of each other, random noise averages out and cancels itself, but consistent features are powerfully reinforced. If there is even a subtle, weak, inherent symmetry in the comet's chaotic jets, the stacking process will dramatically exaggerate it. It is like applying a digital filter that is designed to seek out and amplify any hint of order, and the human eye, looking at the result, will instantly latch onto that amplified order. Furthermore, the delicate process of image alignment introduces profound risks. Alignment errors, even tiny ones, can create subtle, ghost images that appear to orbit the target. If Ray's alignment was subtly off, and the image was slightly rotated between the different exposures, the stacking could inadvertently create a faint, repeating pattern around the center simply by layering slightly misaligned copies of the same image feature. The resulting structure, born from a simple tracking imperfection, would look geometrically perfect, even though it is entirely an artifact of the method. The history of backyard astronomy is replete with these profound, cautionary tales. Astronomers have been fooled countless times. Bright spots that turned out to be simple cosmic ray hits. Galaxies that were nothing more than sensor glitches. Objects that appeared to move because the telescope was slightly bumped between frames. Skepticism is not cynicism. It is a profound, necessary prerequisite for any genuine discovery. This is the central tension of the 3-eye Atlas mystery. We have been presented with a signal, the consistency in inconsistency, that is undeniably real within the data. But we do not yet know if the signal is from the comet itself, or from the intricate, human-designed processing pipeline that extracted it. The only path to quiet certainty requires removing the human pattern-seeking element. It requires an independent, forensic examination of the raw, unprocessed frames, which, for now, remain outside the public domain. It requires the National Aeronautics and Space Administration to release its own high-resolution, multi-wavelength, calibrated data. That data will not be pretty. It will be noisy, filled with raw cosmic rays and instrumental artifacts. But because professional image processing is transparent and rigorously standardized, any persistent geometric structure that survives multiple, different professional pipelines will finally be acknowledged as profoundly real. The human element, however, will not vanish. When the definitive data is finally released, we will see one of two things: either the collapse of the mystery into a mundane artifact, or the profound confirmation of a genuine anomaly. If it is a collapse, the scientific community will quiet down, and the myth of the escorts will fade. If it is a confirmation, the quiet questions will only grow louder. Because, even when the pattern is confirmed to be real, the ultimate question remains: is it nature at its strangest, or intelligence at its most subtle? The human mind, with its bias toward design, will struggle profoundly with a natural explanation, even if the physics is sound. For now, the greatest cosmic truth we hold is not the existence of the 5 points, but the beautiful, humbling fact that a single, subtle image from a backyard telescope has forced the most powerful space agency on Earth to pause and re-examine its fundamental assumptions about the natural chaos of the cosmos. The human reflection is simply this: we are pattern seekers, and sometimes the most profound discovery is not an alien, but the quiet realization of the immense, strange patterns that nature itself can spontaneously generate. Our long, quiet journey to the far edges of our knowledge is drawing to its gentle close. The Comet 3I Atlas continues its deep, indifferent journey away from the warming embrace of our sun, already growing fainter, heading back into the profound, crushing void from which it came. The clock for definitive, close-up observation is nearly spent, and the central mystery remains unresolved. The final, long question is not about the comet itself, but about the profound meaning of the great silence that has followed Ray's initial, shocking observation. The National Aeronautics and Space Administration's prolonged quiet is not, most likely, a cover-up of alien technology. It is a visible, profound symptom of a deeper, institutional dilemma. The agency is caught between the imperative of scientific rigor and the immense, nervous pressure of public perception. The scientific method demands caution. It demands that exotic claims be backed by extraordinary, bulletproof evidence, and the geometric symmetry of the 5 points is an extraordinary claim. To release the data without a completely satisfactory natural explanation would be to ignite a media firestorm that would profoundly distract from every other vital mission. Their silence is the price of their immense caution. But the problem for the agency is that this very caution creates the myth it is trying to avoid. Every day that passes without a definitive explanation, the mythic nature of the escort hypothesis quietly grows stronger. The public, rightly, demands to know what the largest, most powerful telescopes in the world have observed. The entire saga of 3I Atlas and its profound geometric pattern is a powerful, quiet reminder that our cosmic models are merely approximations. They are a framework for understanding the familiar. They work perfectly for the 999 normal comets, but they fail at the edges of reality, and interstellar objects, by their very nature, are all edge cases. They are formed by different stars, under different, extreme conditions, and they are showing us new physical behaviors, new ways for nature to organize itself that we did not have the data to predict. The profound meaning of the unresolved mystery is simply this: the universe is larger and far stranger than we have dared to imagine. The 5 points of light, whether they are a trick of the lens or a profound new physical phenomenon, have fulfilled a deep, mythic purpose. They have forced us to ask the ultimate question: are we looking at natural physics at its most intricate, or intelligence at its most subtle? The answer, when it finally comes, will be a fundamental recalibration of our place in the cosmos. If the points are artifacts, it will be a profound lesson in the humbling power of our own cognitive biases and the subtle dangers of digital amplification. It will remind us that human wonder, unchecked by rigorous analysis, can quietly find a profound geometric design in pure, chaotic noise. If the points are real, it will be a revolutionary lesson in the sheer, immense creative power of physical laws. It will open up entirely new fields of study, forcing us to quietly embrace the fact that comets, the humble, frozen visitors of the night, are capable of profound, geometric self-organization that we did not believe possible. Either way, we will have learned something essential. The truth exists. It is not a matter of belief or opinion. It is a matter of pure data. The scientific method, though slow, is the only reliable light we have. And eventually, the silence will break. The National Aeronautics and Space Administration will speak, and we will know. Until then, we are simply left hanging, staring at those 5 bright points in a quiet, grainy image, and we are asked to find peace in the beautiful, immense uncertainty. The comet continues to spin, the deep time turns, and the subtle pattern remains. The long night passes, and with it, the intense, urgent tension of the unknown. We have traveled far, from a quiet backyard in the night to the distant, impossible orbits of another star system. It is humbling to know that our ancestors survived soup that might kill you, and we survive on the profound questions that might keep you awake. The cosmos does not offer easy answers, only quiet wonder. Thank you for joining this long, peaceful contemplation. May your curiosity rest lightly, and your dreams be filled with the elegant, slow-turning chaos of the universe. History bends, but the fundamental physical laws that govern the light and the silence never break. Good night.